So yeah, you can choose the laptop right now.
I also bring my laptop.
Yeah, can also, but I think my trainer will first use this laptop first, and after that, is the software installed in your laptop?
I have installed the V17.
Version 17?
Yeah.
Okay.
I can use it anywhere.
Yeah, because only one test.
Okay.
There will be one thing. Okay, so anyway, my name is Yogesh Waran. I'm the training organizer, manager. So Mr. Tivan is on the way. He will be your trainer. So I'll just give a quick introduction. And okay, so we have two components. AS Automation Services and AS Automation System Training Centre. So my boss, Mr. Sundaresan, his introduction is brochure and everything. Mr. Sundaresan, his background is he was an ex-army under TUDM. He served as a technician there, and he graduated as an instrumentation engineer. He finished his studies in Royal Australian Air Force. Now he's retired already. Now he's 75. Yeah, he's retired. I'm his son actually. So after he finished his service under the army, then he's from Kedah, so he came here, looked for a job in Singapore in the 90s time, and he did his industrial automation diploma in Singapore, Nanyang Poly there, and then he became passionate with PLC lah. So the first PLC he touched was the very old one, Siemens S5. Still got company running this PLC. Yeah, still got. As long as it's running, they say no problem, they did one. But got problem finished one.
Yes.
So yeah, I cannot troubleshoot that. So as time goes on, he not only touched the Siemens PLC, he slowly moved to Allen Bradley, Mitsubishi, Omron right over there, and even the less demanding type of PLC like GE400, Siemens, and even Schneider PLC also lah. We conduct training. We are only specialized in PLC, HMI and SCADA, and we specialize. We conduct training for a total of 8 type of brands. There's Siemens, Allen Bradley, like I said, Mitsubishi, Omron, then the less demanding type like GE400 and Siemens, Schneider. Even this coming Thursday, for the first time, we will be conducting training in Panasonic, nice PLC. So he after he finished, I think he has around he completed around 35 years of experience in industrial automation. But in 2012, after he finished his last project in Singapore, when he was collaborating with his partner in Singapore, they did open up. We have another company in Singapore, but that one mostly focus on services and projects. Here, my boss, he opened up in 2012, and he mainly wanted to focus in conducting training. So our first customer was from Batam, and from there we kickstart from there. I think until now we have trained more than 3,000 plus participants already. Not only in Malaysia, we used to train for Indonesian client from Mongolia, even from Libya, and even we have a Scottish client also. Mansali also used to come here.
So many.
So your training will be this one will be 3 days, basic to intermediate, right?
Yeah.
That's 1,200 PLC. With in a basic level, he will go through HMI as well. Okay, and then actually, if I don't mistaken, the version in this laptop is TI Portal version 18. But only issue that you can use yours also. Because
the
this
17 and the 18, what is the difference between?
just become upgrade upgrade with better performance and
Function all is
it
same.
clear. Yeah, function all will be same. It's just clear out the previous versions bug, and now they upgrade to version 18. Now it's version 20 already.
Oh, okay.
Now it's version 20. So whatever program you program in version 18 cannot open in version 17, but whatever program you program in version 17 can open in version 18 and above. The older version cannot cannot go. I mean, the new version program cannot open in the older version media. So that is what I know lah. So okay, so I'll just grab your name, IC, so I can prepare your attendance certificate. Or at the end of the training, which is Wednesday, I will give you the hard copy of the certificate, and then the digital copy I will email to you lah. Siemens is actually this one, the water purification process, right?
No lah, it's the lifting equipment.
Oh, lifting equipment.
Yeah.
That's,
I just
that's
type my name.
name according to IC number, and then your email address.
Okay.
And not only training we provide, we also provide services. So that was our first kickstart lah. First we kickstart when my boss opened up this company. He mainly focused on services and project first lah. Then in 2014 only we registered ourselves as a training provider under HRDCorp. And I think this is all training. And Mr. Trivium, he joined us in 2015. He was completely trained by my boss. And unfortunately, my boss had to retire because of due to his health condition. And he take over. His background is mechanical. He now become automation engineer already. Okay. So yeah, like I said, sweets, water bottle are right over there. If you need to grab a coffee, feel at home. Grab a coffee, the 3-in-1 coffee, tea, cookies, all in the pantry. You can bring it over here, just make sure you don't spill it.
Okay.
Alright, I'll pass it to you.
Okay, now please.
Tan. T-A-N.
Can you use this laptop?
Okay.
So you're from Siemens, right?
Yeah.
Okay.
May I know the password?
121.
1212.
No, just 1 2.
Oh, that's 12. Okay.
Yeah.
Yeah. So, Wi-Fi password and username is right over there. You grab it, and today did you bring a car?
Yeah.
Yeah, I put coupon for you.
Oh, good lah.
Under
That
MB,
means you apps okay lah.
I think so should be because this is under MBJB.
Oh, okay.
So normally I use the MBJB, their main app. Because got heavy rain, never rain, but no rain, so they will show up. Okay, just take your time. I think it should be MBJB app. MBJBT.
Yeah.
This one.
MBJB Sport, sorry. Yeah, that's the one.
Oh.
Yeah.
your background is
My background is electrical engineering.
electrical. Okay. So, have you touched about PLC before? Any PLC?
I joined Siemens, yes. But before that, I am the fresh graduate.
Oh, okay. So means this is your first job lah. Okay. So how long ago?
1 year.
1 year. Okay. So in this you touch on PLC lah.
Yeah, I use, yes, I touched it.
On the programming part or just on the hardware side?
I just learn a bit lah because I'm not familiar with this.
Okay, okay, okay. So your students they using this model? This one is the 1200.
Yes.
This model ah.
Mm.
Okay. But so all the model is Siemens or they have others also?
Others also.
Others also other brands ah.
Got the Wago,
Wago, okay.
and we use the EPAD.
EPAC.
EPAD is not the PLC lah, that is the.
Oh, okay, another control system lah.
Yeah, yeah.
Okay, okay. Alright. So this PLC, Siemens, okay, just now you showed about all the PLCs we have, right? So we have so many brands here. So you can see, all the PLC are same. Okay, all the PLC are same. Only the software is different. Okay. So example, this one, okay, for Siemens, this model they're using TIA portal. Siemens, the previous model using different models. Okay. Right. You can close this one. Close this. So you can create a folder for you. You can create a folder. Just right click here. Create a new folder. Yes. So you can put your name. So whatever project we do, okay, so we can save it here. So on the third day you can copy your files. Okay. Alright. So you click open Siemens there, yes. Okay. You can open this in the PDF. Okay, you can go all the way up. Okay. So this training is your Siemens training, okay, using TIA portal for S7-1200 and 4500. Okay. So now they already have TIA portal version 20. So do you know what version your company is using?
17.
17.
17 and 14.
17 and 14. So these are the Siemens models. All are Siemens models. Okay. Okay. Go to next. Okay. So first, but you touch on PLC before, right? Okay. So you know what is PLC? PLC is very simple. Industrial controller. Okay. So if you want to automate anything, you want to get the machine data, if you want to get want to create some alarms for the machine, so you can use a PLC, whether it's a small one or big one. Okay. So this one just for example only for assembly, oil and gas manufacturing. So means even in your home you want to automate home, you can use your PLC also. Okay. So PLC is just a controller where you connect the input, you write a program, then output will on and off according to your program. Okay. Similar to, have you heard about like microcontrollers like Arduino? Have you heard about Arduino? No, right? So it's similar thing like PLC also. Okay. But Arduino more to, it's not like industrial standard. but they have some models lah. Some models they have industrial standards, but mostly the small one, right? Like the
Yeah.
projects you can use, yeah. Okay. So PLC is very simple. For example, okay, like our aircon, right? So our aircon also they have a controller inside, right? Okay, a PCB board, right? Okay, so they connect all the input outputs. So for example, this is their inputs. Okay, similar to our touch panel. In our machine we have a touch panel, right? Okay. Then this from here I send a signal to the aircon, and the aircon will on. Okay, it will blow the air, everything, right? Then they will have a temperature sensor. Okay, let's say you set at 23. So the temperature sensor will detect the room temperature at 23. Then if not 23, then it will on the compressor. Okay. I can remove the board. I can fix a PLC. Then I can change this into a HMI, a touch panel. Then I can on and off our aircon using PLC. Normally they won't do that, right? Because okay. So if what is the difference between the PCB board and the PLC, right? Okay, PCB board they already fixed. Okay, one compressor, one temperature sensor. Okay, then you get the frequency from the controller to on and off. But if you are using PLC, let's say I want to add another compressor, I can add another compressor. If I want to add another temperature sensor, I can add another temperature sensor. For example, the temperature sensor is in the box, right? Okay, in the unit. So let's say because it only measure the temperature there itself. But let's say if I will put a PLC, I can put another temperature sensor here. So it can be so let's say that temperature sensor is 23 already. But here the temperature sensor won't be 23, it will be more. So the aircon can depend on this temperature sensor. So you can control the whole room temperature. So that is the difference, okay, between the PLC and some PCB boards. Okay. So very simple, you can program. Okay, how you want to program, you can program. Next. Okay, so these are the CPU models on Siemens. Okay, Siemens, if not mistaken, they started back in 1958. Siemens brand. Okay, they come into the industry. Okay, so when the industrial revolution, right, they start to use electrical. Okay, then only they start to come up with computers, right? When the computer age coming up. So first one they use they call SIMATIC controller. Okay, which is not a PLC. We cannot program it. Okay, so it's already like is pre-programmed. So you just connect all the input, then output can go. Then they come up with another controller called S3, SIMATIC S3. So that one also is not a programmable. Okay, it's a controller. So like they already have a program inside. So you just put on and off. You can play with the switch there. So you can control some system. Okay. Start with S5. It become a programmable controller. So that is S5, the white color. Yes. Is if not mistaken, is late 70s PLC. S5. So, but still some companies using still some company in JB also they using. Steam is from Johor, right?
Yeah.
Okay. Where is it? Steam is? Okay. So here in Tampo industry area, Tebrau industry area, I know one company still using that PLC. In Senai also, because normally we don't only do trainings, we do projects, we do troubleshooting as well. So I do troubleshooting Johor area many companies. So still some companies, old companies are still using the PLC. You know, it's a late 70s PLC. I think more than 40 plus years. Still using.
But it still can work properly.
Yes. Still because last time last time our machines is like just like PLC just control the system. That's all right. So you won't take the, like nowadays you can use SCADA to take the program. Nowadays you can send the PLC data to your cloud system or like, so last time you cannot do that, right? So if they properly maintained, still can use. Even this device still can work. So I just keep as a spare part. Because we also sell spare parts, some spare parts. So sometimes some company will request for, but this one all nowadays you cannot get, but already obsolete already. Okay, so if they using step 5 software, okay, it's a DOS based software. You know the blue color window, right? Last time. Okay.
Is same with the now?
Windows, right? No, not these Windows. You know, like Windows. Okay, let's say for example, suddenly our Windows not working. We will open the BIOS, right? The blue color window. They use something like that. Very good. So you can use the mouse. You just use the keypad and the shortcut key F1, F2 to put in the address. Then they will have a key. Then only can download, upload. Okay. Even it can only run in Windows. Windows 98, Windows Millennium, Windows XP. For Windows 10, they released a new version of the software. Okay. Then they have so this is the in PLC. This is the first generation. According to Siemens, SIMATIC. This is the third generation. So first they have SIMATIC, then they have a SIMATIC S3 controller, then S5. But in PLC programming, as a PLC, this is the first generation. Okay. Then this is second generation. These two, the S7-1200, 300, 400, 8200. Okay. So S7-1200 is this model. This model. Okay. Then it's using micro-win software. Okay. Micro-win software. Then the same generation is the 300. 300 is this one. In front of you. This is 300. This is 400 at the back. This is 400. And this is ET200. So this and this, the 400 are using the same software. They call SIMATIC Manager. Okay. The 200 is using micro-win. 200 is normal 200. They're using micro-win. Okay. Then they release a new version for the 200. They call S7-1200 Smart. Okay. So this one is using micro-win Smart. Okay. So what happened, because this model, the 200 only don't have Ethernet port. LAN port, they don't have LAN port. Okay, they only have they call serial port. Can you see the 9 pin there? 9 pin serial port. That's a port. Yes. Okay, this. So they have this, the 9 pin port. Okay. Then in 2010, they come up with the TIA portal. They release a new software. They call totally integrated automation. Okay. New software with new hardware. So the 1002 and 1005. So this is 1002 and this one is 1005. Right? Okay. At the same time, in TIA portal, you can program the 300, 400 and the ET200. Okay. Okay. Why? Because what they do, they combine. Okay. So previously, they have a SIMATIC Manager. These are the software, the software name. SIMATIC Manager. Okay. So this software is for to program S7-300, 400, ET200. Okay. So these are the models. So PLC goes. Siemens got so many models. Okay. So when the SIMATIC Manager, okay, they're using these models. Okay. So So the software name they call SIMATIC Manager. Okay, but if you go inside, deeply inside, okay, the software to create the logic, the ladder logic, they call, actually this is the hardware, the software, they call, if you buy license then only, okay, they call Step 7 Professional. That is the license you buy for to program a PLC. But the software name they call SIMATIC Manager. Okay. Then for touch panels, okay, they use WinCC flexible. So this one for the SIMATIC HMI. So you know HMI, right? Touch panels. Okay. So to program the Siemens HMI, you need to use this software, which is Siemens. So to program these models, you need to use SIMATIC Manager. Okay. So then to SCADA, you know SCADA? Okay. SCADA is a visualization similar to your HMI, but in a bigger scale. It means it's mostly on a computer only. It's a PC. So they don't have a dedicated screen. Okay? Like HMI, they have a dedicated screen, right? But no, for SCADA, it's a computer. Okay? So mostly, but later we go deeper into SCADA. Okay? So very simple is that HMI is to control your machine. Okay, like one machine. You have another machine, another HMI, right? Okay. So if you want to monitor your whole plant, so you connect all the PLC into this card. So inside this card, you can see your whole plant. So machine A, what is the status? Machine B, what is the status? Something like that.
It's like a database.
Something like that. Okay. Database, but mostly database is just like you store all the data value, right? Similar to that, but it's more to visualization. So like exactly same like the HMI, but normally in HMI it only for one machine. SCADA means it's like all the machines. So later I will show you the examples. So what happened? All these. So for SCADA, Siemens they use WinCC. They call Explorer. Okay, so in previous generation, I mean in the SIMATIC Manager, so they use SIMATIC Manager to program the PLC, they use WinCC Flexible to program the HMI, then they use the WinCC Explorer for the SCADA software. So what happened, we combine all these three, we come up with TIA model, the new software. Means we combine all into one. Okay, so inside here you can program S7-1500, 400, 1800. Then they add a new models S7-1200 and 1005. Okay, then you can program the HMI. The Siemens one. Then you can do a SCADA also. All together in one software. Okay, so that's why the software is very expensive. Okay, so you said you have a version 14 and 17, right, in your company. Is it you're using normal laptop or Siemens laptop?
Normal.
Normal laptop.
I bring my laptop.
Oh, you bring your laptop also. Okay. So this is about the Siemens history. So this one is started with 2010. Yeah, version 10. And this only regular version 11, 12, 13, 14. Now it become version 15. Okay. But if you want to use a TI-400 software, your laptop must be a bit powerful.
Yes.
If you know, left. Even my laptop, You see the 64 GB RAM, SSD. Mostly important is the SSD, the RAM. These two, like graphic card also not is not so helpful. Normal graphic card is enough. Okay, but these two, even sometimes I open, I need to wait for a few seconds. So, but once you open, then it's okay. Once you open already, then you go to the logic, see the logic, do the troubleshooting, is okay. But when you want to do projects, especially projects like when I do projects, because that's why I put 64 GB, because when you do projects, not only open TI portal, so you open TI portal, you open some documents, you will have a flow chart, everything, the IO list, everything up. That's why normally when I do projects, programming part, night time only. The work go back, the makan and everything, then 10 o'clock something, then only I sit. Must be quiet. There's no cannot do. Okay? Good? Yeah? Okay. So this one you want to take picture or take note can. Okay? Alright. Go to next page. Okay. So this is how the PLC works. Okay? Very simple. So PLC at the same time they call a CPU as well. Okay? A CPU again. But CPU means it's just a CPU. If PLC means it's like a CPU, input, output together they call as a programmable logic controller. Right? Okay? So the inputs, what are the inputs? We have normal is digital and also analog. Okay, these are the two types of inputs. Okay. Then I connect the input, I program the PLC, then the PLC will enable my outputs on and off or give some values. Okay, say digital and also analog. Okay. So what is digital? Very simple. Digital signal are just on or off signals. Okay. So sensor, limit switch, push button, selector switch, proximity sensors, all that. So very simple. Any signal is just on and off. We call it as a digital. Okay. Analog means any signal come with a range, give you value like temperature, pressure, flow, humidity. If you want to measure the current consumption, all that. Okay. So it's because they must have a value, right? Must have a range. Then only we can know, okay, what is the temperature, okay, whether it's high or low. Okay. Then the output also same. Output, they have a digital and also analog. So digital very simple, lamp, contactor, relays, what to connect the motors, open and close the valve, solenoid, all that, right? Then analog output like a controller, motor speed, inverters, right? Controller motor speed, controller pump speed, controller valve, all that. Okay. And most important is the software. Okay. So the software and the cable, what type of cable you are using. Okay. So nowadays it's okay, all using Ethernet. But you see the other models, right? All different cables. Yes. So this one they call MPI cable. Can you see the MPI cable? Right? Okay, so we must use the MPI cable. Then this one here. So this one is another cable. Okay, they call a TTY for this one. Okay. Then for S7-1200, also same like this, but you cannot use the same cable. Must use PPI cable. It's a different cable. So last time, that's why you can see I have 3 boxes of cables there. All different PLCs, all different type of cable. Even the same connector but different communication skills.
But this one can integrate with a small PLC, right? I'm not sure.
Okay. You mean this one?
I think yes.
Yeah.
Can
Add on the input output. Yes. Yes, sure. Now this one got error, right? Because of that also. You see got error, right? Because that day for my previous training, I had the module here.
Yeah.
So So for this training is removed, so that's why got error. So that one we call not a PLC, that one we call a IO module. Yes. So because sometimes our project not enough IO, so we can add some IOs. Okay. Alright. Next. Okay. The most important part. When you want to start the PLC, when you want to program, or when you want to start programming, or you want to troubleshooting the PLC, the most important part is this one first, because this is the very basic one. Okay? Actually, all this we learned before. During your study time we learned before. Okay, but I think we don't apply that. Right? Okay. Then now we're going to apply the PLC. So decimal, hexadecimal, octal, I think in universities we don't learn octal. Okay, mostly we learn decimal, hexadecimal and binary. Okay. Okay, next. Okay. So decimal is the normal number every day we use. Okay. It's a 0 to 9, then 10 to 19. 20 to 29, okay, the normal number every day we use. So this one is very common. Okay, so you see like a SIMATIC HMI, right? HMI, they sometimes they have a value, right? So you can see mostly they use the format decimal format because easy to understand. Okay. Then they have a hexadecimal format. Okay. Hexadecimal is mostly used in PLC, computers, and some digital devices. Okay. So hexa means 16, right? They have 0 to 9, then continue with A to F. Okay, so total 16 numbers. Then they will go to the next batch, like 10 to 19, 1A to 1F. Another batch. Then 30 to 39, 3A to 3F. Something like that. Okay? But this is like earlier, it's the older formats. Okay? Why they created these? Because this number, if you go bigger, right, this one can reduce the digits you are using. Later I can show you. Okay, the digits I'm using, I can reduce the digits. So that's why last time they used hexadecimal in computers. So since the PLC also is a computer, right, so they use hexadecimals. Okay, but I think for basic to intermediate level, very rare using hexadecimal. But I will tell you where we use hexadecimals. Okay, normally hexadecimals, for example, if you want to control the Siemens drive, this is the Siemens drive, right? This drive will control this motor to turn. Okay. So if the PLC is connected to the drive using the LAN cable to control the drive, okay, on and off or rotate everything. So what we need to do, okay, we need to open up the Siemens the inverter manual. Then we need to go through the manual, okay, to check, okay, what is the value you need to from the PLC need to send to the drive so that the drive can run full speed. So if you open the manual, normally in the manual they will use hexadecimals. So whenever we see some numbers, okay, we need to understand this is hexadecimal or decimal. Easier is just alphabets. But another way is normally they will mention them in the manual. Okay, let's say in the manual just put like this 4,000. So you cannot know whether it's a decimal or hexadecimal, right? So if decimal, normally they don't put any symbols here. So they just mention number. Okay. If hexadecimal, normally they will mention it's a hexadecimal. So any manual you take, they will mention it's a hexadecimal. So easy to find out. Okay. So when you want to do programming, it's up to you whether you want to use hexadecimal, this value, or you want to convert this into decimal, and you want to use that value. Okay. So if you convert this, if I'm mistaken, 16,384. Later I show you how to convert this. I think so. Because this is the common number that I normally use. Okay. binary. So binary we know is 1 or 0, right? Okay. So whatever these values we key in to the PLC to run a motor or something, of course the PLC will process inside using binary. Okay, it's just a 1 or 0. Okay. Then the last one is octal. Okay, octal, if not mistaken, normally we don't learn in universities or something. Okay, normally we only learn hexa, decimal, and binary. Octal very right. Okay, octal mostly used in PLCs. Okay, some early PLCs they using octal. So that's why Siemens they using octal. Okay, why Siemens they use octal? Siemens they use their format. Right? Okay, you know the address, right? For input they use I, right? For output they use Q, right? So for the address format, they use octal. Siemens. So other than this one, Mitsubishi they use octal for the addressing format. It means they only have 0 to 7, so they don't have 8 and 9. Okay. So even this this Siemens also, right? So you have I 0.0 until I 0.7. There's no number 8, no number 9. Okay, same like Mitsubishi. Some model some Mitsubishi, Panasonic, Delta. Mostly Japanese PLC, yes, they use octal. Mostly like Delta, Mitsubishi, Panasonic, Siemens, all these Japanese models use octal. Okay, right. Go to next. Yes. So this is one example. So the difference between the decimal. So decimal, hexadecimal until the 9 is same, right? So octal until 7 is same. So octal is this 0 to 7 is the 8 number. 10 to 17, another 8 numbers. So this is total 16, right? 0 to 9, then 8 to 10. So this one is normal number lah. So 0 to until infinity. Okay. Then this is in binary. So if we convert these numbers into binary, it become 1, 1, 1. Okay. The thing is, in our schooling time or even our university time on, they teach you how to convert this number to decimal, all that, right? Hexadecimal, okay. So actually we don't need that because nowadays our computer calculator already has that. Have you used before the computer calculator?
Yes.
Okay, good. Because you know, most of the training I do, most of the people they don't know the calculator.
Oh, because my college got
They teach.
teacher.
Okay.
So
Good.
teaching
How to use them? Okay, good. Actually very useful. Even sometimes some of the programmer, actually they are programmer. So let's say they are programmer for Mitsubishi. So and they suddenly got a new project for Siemens, right? So they don't have the time to practice themselves. So sometimes they will come for training. So they know already everything. Advanced, until advanced they know everything. Only thing is they don't know is how to use the Siemens software. So they come for training sometimes. Sometimes they also don't know how to use the calculator. They never used before. So then I ask them how you use. They say they just go to Google. Just go to Google and just convert the value lah. Okay. Because you won't be using like when you do programming, you won't be using for every part of the programming. Sometimes, for example, like this. Okay. So while I put 4,000 as an example, okay, this is the value you need to send from the PLC to your inverter to run the motor full speed. So in the manual they will put 4,000. But when I want to do program, it's up to me whether I can use this this number or this number. Okay. Alright. So you know how to use the calculator. And go to next. Yeah. Calculator, right? Go to programmer, then you will get all this. So this one, because sometimes some people thought this is a special app need to install. No, it's already there. Even in Windows XP, Windows Millennium, all that, they still already have this programmer. Because why? Because programmer calculator, not only the PLC programmer will use, the computer programmers also they will use these numbers. So mostly they use hexa, decimal and binary. Okay. So like this example, you see in decimal 100, so it's already 3 digit, right? But you see in hexadecimal is still in 2 digits. So that is the reason they use hexadecimal like this. You see 4000 in hexadecimal is just using 4 digits, but when you convert to decimal it's already 5 digits. So that's why the earlier computers, all that, they created hexadecimal. Actually, that is the reason to reduce the number of digits. So for them to do calculation, I mean last time now, okay, tell like 50-60 years back. So they reduce the digits so they can easy to show, display, okay, easy to display, easy to write a program for them. Okay, alright. Okay. So any question before we go? Any question on the software, the numberings? So if you are not clear anything, just can ask me questions. No problem. Okay. Now Siemens PLC addressing. One good thing about Siemens, all the models, we see all the models, right? All the models is the same addressing method, not like other PLCs. Like some PLCs, like Mitsubishi, you see here, this PLC and this one are not same. The in term of addressing, this is using octal method. The number, so it's 0 to 7, then 10 to 17 and on. This is the same Mitsubishi, but using hexadecimal method, which is not same. So sometimes so some Omron, okay, Omron all same all same method. Okay, Omron, this is a new Omron, totally different. This is the old Mitsubishi, this is the new Mitsubishi, still the same thing. Okay, then we have Kiers, Panasonic, Sumi. But actually, Siemens all same. So if you learn, let's say you are learning for 1002, 1005, the same knowledge you can apply for 300, 400. So if the same knowledge you can apply for the 200. Okay. Okay. So Siemens PLC is using octal numbering method. Okay. So it means they using byte system. So they come with a byte. So byte 0, byte 1, byte 2, byte 3, so on. Okay. So the byte 0, okay, inside one byte I have 8 bits. They call bits or boolean. Okay. So bit or boolean means it's a 1 or 0, on or off. So inside byte 0, okay, they have input byte 0.0 until 0.7. Once finished, they go to the second byte. So 1.0 to 1.7. Okay. So when these two bytes together, it become a word, one word. Okay, because that's why sometimes you in your program you can see I 0.0 and suddenly I W0. Then I double word. Okay, it means the two word together join, it become double word. So the I input you can use as a bit, you can use as a byte, you can use as a word, you can use as a double word. So it depends on your programming. But mostly inputs, they very common is the word and the bit. Okay, it's not commonly we can see, but this is how it operates. But in the programming, not very common. We see suddenly IB0 or IB1. Normally this one and this one. Why? This is for your digital inputs. Like I said, bit or boolean is just on or off. Right? So this is for your digital inputs. This one is for your analog inputs. Because why? Inside here I have 16 bits. If all the 16 bit is 1, 1, 1, 1, 1, it can become one value. Right? In binary, then it's in decimal become one value. Right? So inside here I can store some values. So that's why the analog they use IW. Good. Okay, good. Go to next. Then the output they use Q. Same concept. They use Q. Okay, next. Then memory they use M. Okay, next. And data block. Okay. So just now the input, okay, you know, is a physical input. Output, okay, is a physical output, right? Okay. Then we have a memory and a data block. These two is a memory, means it's inside the PLC. There's no wiring for this, correct? Input, okay, we have to connect the cables like the wires, okay? Output, yes, must connect the cables and wire. But memory and data block is only inside the PLC. Okay, why they use? Because to process, to run the program, to share data, share values, okay, share the data to your HMI. So in the HMI I can see the values, I can press the buttons. For this only they use the memory and the data block. Okay, but later I will tell you what is the difference between these two. Okay, because both are same level. It's a memory, both are memory. The main difference is data block can keep the value, can retain the value if you power off and on, or if you reset the memory. Data block can keep the value. Memory cannot keep the value. It becomes zero. Okay. Okay. So this is about your hardware. Okay. So here is the power input. Okay. So some model is a DC input, some model is the AC input. Okay. So how you know is it a AC or DC input? From the part number you can know it. Okay. So can you see DC, 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 right? The first one is, okay, can I erase this?
Yes.
So 1212 or 1214 is the model, okay? Then C. C means it's a compact model. Compact model means, okay, CPU come with the input output. We call it compact. Okay. So for example, you can see here. The one is the 1212C, right? It means they have an input output, right? It's a 1511C. So this one is this is the CPU. There's an input output cards. If you see this one is just 315. Only there's no C. It means this is only the CPU. So you need to add the modules. Okay. So normally for 1200, all the model is they have a C at the back. It's a compact. Okay. So the 1500, if not mistake, only two model is a compact. The rest of the model is just the CPU only. Okay. Then they have a first one DC, right? So they have a AC model also. Okay. Then the center one is always DC, and the last one is the DC or relay. So this is the main power. Okay. Power input. So DC is 24 VDC, AC is 230 VAC. Okay, power input. This one is the inputs. Okay, the input. So always DC lah. Okay. Then the last one is for the output. So it's a DC and also the relay type. So DC is a 24 VDC. Relay is, you can use 2230 VAC, 24 VDC, all can. Relay model. So this is how we can know the model, what model we want to use. So let's say when your PLC, let's say your model is already spoiled, you want to buy a new one. Okay. This one actually not very important. The most important is this two. So let's say your, of course the center one is always the same thing. Okay. So only the last one actually. So if let's say yours is a DC model, so if you want to buy a DC model. So the power input DC or AC is not an issue. I said earlier is AC, but the new one you buy a DC. So only thing is you need to add a power supply like this, additional power supply lah. Okay. Then, so this is the power output. It's been just because okay, once you connect the 24 and 0 volt here, then if you want to use the 24 and 0 volt for my input or my output, I can use this. Can use that because it's like inside here is just like a terminal inside there. Okay. Then we have digital inputs. Okay, digital inputs. Then we have analog inputs. Okay. So because normally for 1200 they have digital and also analog together. Okay. But they only have input. So 1212, 1211, 1214. They have only input. Then they have another two models is the 1215, 1217. These two models they have analog output as well. Okay. Okay. Then here is the memory card slot. Okay. So your PLC is using memory card. Okay. Because if you ask me, memory card is not necessary. Because the PLC already have some built-in memory. If your program is more than that, you want to do some data logging or that, then only you need a memory card. Okay. Then here you can see the model, and here you can see the part number. Okay. Or at the side also you can see the part number. Okay. Then here is the output. Then here is the Ethernet port, right? Okay, but Siemens they call Profinet. Okay. Then the option port. Okay. Option port, if you want to add some I/O module, additional I/O, you can add here also, or at the side also you can add. Okay. Then here is the run, stop, error, and the maintenance line. Okay. So run, of course lah. There's a when the machine is run, it's run lah. Okay. If the machine got error, it will go to stop mode. Okay. If the machine error, when the error, so like just now. So if this model I take out, if the extension module I take out, or this one I take out, okay. And let's say this Ethernet I connected to some device. Suddenly the device is disconnected. Then I will have an error. Okay. Then maintenance. Maintenance. When you do maintenance for this, then the lamp will on. So later I'll show you what is the maintenance lamp. Okay. Right.
So just double check the numbers here. And then just any.
So this one is like just now we see that the 8-bit, right? But so when the byte is means if the 8-bit is 111111, then you will get 255 this number. Okay. The same thing. If all the 16-bit is 11111, I will get 65535 in the word. Okay. So it means I go back, go up. Up some more. Yeah. Okay. I can go up some more. Go to the input. Okay. So it means here I only can store the value 1 or 0. I can store that only, that value only. So it is inside I 0.0, which is we call a boolean. We can store value 0 or 1. Okay. If I'm using a byte, input byte 0, which is called byte. Here, inside here, we can store value 0 to 255. So, because inside here I have 8 bit, right? So, if all the 8 bit is 1, 1, 1, 1, 1, we get this number. Okay. So, input word 0. So, this is called word. Word, I can store 65535. This big number. So how I get 65535 is because inside one word I have 2 bytes and 16 bits, right? So if all the 16 bits 1, 1, 1, 1, 1, we will get this number. Okay. Then the last one is the ID0, which is called double word. Inside here I can store very big number. So just put 4.2 billion the number. Okay, but don't worry. For now, today we will learn more on boolean, and tomorrow on we will learn on these numbers. Tomorrow and Thursday. Okay, so that is the reason they have different type of data. So this one we call data types. Okay, different type of data. Why? Because why they have different? Because they need to store values. Keep the values. Okay. What next? Yes. Okay. Go to next. Okay. So this is the data and the values. Okay. But don't worry, this one later we see. So now, then you should see now later you confuse. Okay. Okay. After this, no need. After this, can minimize. Later we can open back. Okay. Yeah. All this analog. You go up.
Go up.
Yeah, go up, scroll up, scroll up. Okay, stop there. So until here, any question? So far, okay, yeah? Okay, so now what we do? Now we try to back up from the PLC to your laptop. Okay, okay, minimize here. Okay, you can minimize here. Then you can open the TIA portal. In Stinis, who taught you how to use the software? Who teach you?
My one senior and my manager. But mostly the most teach is the senior because I one office with he. So what we do, go to create new project first. Okay. Then just put a name. You can put as a day 1 upload. Then the part, yeah, click here, you choose your folder. So you have your folder in the desktop, right? Okay, then create.
very simple. You can click here, just one click enough. Okay, any of this. Just click, okay, then you can go to online. And no need to add any ones. Because we want to do a backup, right? So just can select one of these, can go to online and upload. Okay, but don't click first. Okay. So that is very simple step, right? So you just open up your TI portal, create a new project. There is one, once you open here, this one we call a project view. The earlier one is we call a total view. Okay. Then just click here and go to upload and can upload it. Okay. But before upload, we need to know two things. Okay. Then only we can upload without any error. Number one is, what is the TI portal version they use in the hardware? Okay, because that's why your system you have version 14 and 17, right? Because it means some of your PLC is version 14, some of your PLC is version 17, right? Because this is the PLC, this is the PC. Let's say the PLC is version 15. Okay, so it means your PC also must be version 15. Okay, then only can upload. Okay, then only can upload that backup. Okay, let's say yours is version 15, but you want to use version 16. Cannot upload. So must use the same version. So let's say yours is version 16 and yours is version 15, for example. So cannot upload. Okay. Release resources by closing. Yes, close this one. Close. Wait now. Since I'm done with this. Just close this one. Just click this button. Open it. Let's say it should Windows update nowadays. So many problems in Windows update. Okay, I think we go to browse. I think your folder will be there. Go to desktop. Yeah. Okay. Yes. Click here. Open project view. So to know what is my PLC version, right? You can go to the online access. So before upload, you can go to the online access. Okay. So the laptop, what is the laptop Ethernet adapter lah? So normally this one lah. Internet connection. Okay, click here. Okay, then update accessible device. So you try to search. Okay, the internet is connected. Okay. So you get one PLC, right? Okay. Open. it shows might not be trustworthy. Okay, let's go ahead. Okay, so you see, if sometimes it can connect like this, it means your laptop IP address need to change to this one, similar to this. The first three number must be same, last number must be different. Because if the laptop IP address is not, you cannot communicate, then you cannot open sometimes. You only can detect the PLC but cannot open this. Okay. So from here we can know what is the version of the version of the TI portal project. It means previously I used version 18 inside the PLC. So now you are using version 18, so you can upload. If different version ready, then you need to have a different version TI. Okay. Then this is the firmware. Okay, 4.7 is a new one because that PLC is very new. I think 2 months back only. So it's a 4.7, it's a new version. Okay. Okay, why error? Actually we can know why error from here. Go to diagnostic buffer. Okay. So this one can close. Yes. So you click on this. Yeah. Okay, so you can see here. So new IO access error during process image update. Okay. So it shows hardware ID 24, input 84. So it means some IO is missing. Okay. Alright. Okay, no problem. Later we can solve the issue. Okay, so now we know already what is the issue, right? So you see, even though you didn't upload the program, you can see what is the error. That is the main thing. Okay, you can know what is the error. Once the error is okay, then so once you know this PLC is using version 18, your laptop also is version 18, now you can upload. Now you just click here, click on the add new device. Go to online, on this. Just click on it and go to online, upload device as new station. Yes. Okay. So this one you know right? Okay, so type of VGPC interface is a PNIE. PNIE. Okay, what is VGPC? PC is our laptop. Okay, what is PG? Actually, in German they call PG. The laptop they call PG. Okay, that's why they put PGPC interface. PNIE is Profinet or Industrial Ethernet. Okay, then start search. Okay, I found a PLC. Okay, then upload. This is upload. First thing is we save first. Yes. So this is the backup file, right? So normally the backup file is very important because you know why? Sometimes the PLC got error, spoiled already. So if we have this backup file, you can download back to another PLC, another model. You can buy a new one. Okay. So you can open. Yes, and go to program this one I use for on project. This PLC, then they asked me to upgrade to PLC, so I buy another one, 1214. This one, so there's a project. Okay. So you can open inside. Have you seen your programs before? Okay, because I'm using some block diagrams. Okay. But go to device configuration. I will tell you why error. Okay. Yes, you can close this. Yeah. Yes, so this PLC got analog input, two analog input. Because actually I'm doing a project in UTM, for UTM. So that day I used this PLC with the two analog input card. Then for last minute they add some additional IOs. So then I cannot use this PLC already. So I changed another PLC, 1214. So this one is still in the machine, that's why I got error. Okay, good. Okay, any question until here? Okay. So we take a break. Okay. So if you want a coffee or tea, you can make a coffee or tea. Okay, you can bring it also. Okay. Then after the break, we continue. Okay. Yeah, normally lunchtime, like 5:30 to 1:30. Is it okay? 5:30.
Oh, 12:30 to.
Yeah, 1:30.
Okay.
Is it okay?
Okay.
Yeah, because it's a flexible.
Oh.
So no problem. Because only one packs, right? So not an issue. So if or what time you want to go for lunch? It's up to you, no problem.
Normally I also go 12:30.
That's okay, yes. Because normally one packs, yeah, you can be flexible.
Yeah, sure.
More than one packs, yes, then we need to discuss, we need to fix the time.
Okay.
Okay, good. So this is upload, just now upload, okay, okay. Now, what we do, go to project, we create new project. Project new. Okay, so you can put day 1, lesson 1. So can I have this?
Okay.
Then, so if we doing new projects, then we can add new device. Add new device. Double click. Okay. So can you see TI portal? You can do for controller. Click controller. Yes, controller 1002, 1005, 300, 400. Can do program for HMI. Can do program for PC system, that is the SCADA. Okay, all this. For this one, you need to install separately, like the software for the drive software. Okay. So now we're using 1002. Okay. Open 1002 CPU. Okay, can you see? So all these are C, right? Can you see? All compact model. Okay. And these are safety PLC. With the FC, this is safety PLC. Okay. Okay, what is different between normal PLC, safety PLC? Safety PLC normally they use for in like any safety systems involved, like in the oil and gas. Okay, because they have this all the safety functions right now. Because inside here they have additional safety functions. That's all. Other than that, it's a similar thing. But even you can use your normal PLC also for that safety system. Okay, but normally, you know what? Because when you involve safety in like industry like oil and gas, they have their SOP to follow, right? So they may they say the PLC must be in this standard, so you must use that PLC. If they don't put anything on the controller, the controller can be any controller, then you can use normals. Okay, because not the safety is normally what we will just normally will detect any gas leakage or any temperature, pressure leakage, all that. Then it will shut down all your system. So that is the main function normally. Okay. So ours is what? 1212C, okay. DC, okay. Click here. Okay, you click open. Okay. Now we have 3 model, right? Okay, so you can at the side you can see the model number S6E S7. You just don't double click, just click on it. last one. Yes. Okay. So you can see the part number here, right? Okay. At the same time. Okay. See the part number here. Okay. Alright. So the version is 4.6. Okay. Remember just now when we scan here, right? It shows version 4.7. Correct. Okay. Because this PLC is new. So only 2 months back I buy this PLC. So they come with a new version. They call new firmware, right? Firmware, okay. But this TI portal 18 only up to 4.6 only. Okay, so it means my PLC is 4.7, my software can choose up to 4.6 only. So no problem, still can use. Okay. Only you cannot select higher version. Let's say mine is 4.5. Let's say that the hardware is 4.5, but here I choose 4.6. This one cannot.
How can I know the version for
Just now when we do the scanning,
Oh.
remember? So we see the TI portal version, right? Above the TI portal version, you can see the firmware version. Okay. But normally because this PLC you cannot see. There's no display. This PLC, yes. Later I power up. Your company using this model?
No.
No.
I never seen it.
No, they only use these models. Oh, okay.
This also got, but I never program it.
Touch before lah.
Yes.
Oh, okay. This one, you can use TI portal to program or SIMATIC manager. This one also is depend. Is okay. This one also just now we scan here, right? Just now we scan here, right? Okay. That PLC also can scan. Okay, but if you scan, let's say it shows the TI portal version, it means the programmer used TI portal to program the PLC. If it didn't show anything there, it means they're using SIMATIC manager. So later I can power up that also. I can show you. Okay? Alright. So you know where to get the version, right? Okay. So what is the difference? Okay, you click here. Click on the version. You just select version 4.0. That's the lowest one. I think 4.0 is the version is 2013-14 on that time. Okay, you see version 4.0, the work memory is 50 KB. Okay, so means the memory to do the program is very small. Okay, the rest are same. So got 8 input, 6 output, got 2 analog inputs. Okay, blah blah blah. Then Profinet interface for programming. Then so Profinet is for programming, HMI and PLC to PLC communications. Okay. Okay. Because I'm supposed to choose 4.6. I mean, I can change. Okay. Right click the PLC, change device. Okay. Go back to the 1212 DC, yes. AE, okay, just click once. Okay, then here's it. Okay. So what's the difference between these two? Okay, actually in the key we do like this, you can see the difference. So this is 50 KB, this is 100 KB, right? Okay, go down. So this Profinet, okay, this Ethernet, just for programming HMI and PLC to PLC communication. But this Ethernet here, they update to the Profinet can be a TCP/IP protocol, which is TCP/IP like an Ethernet protocol. Okay? Then can do web server, can do OPC, all that. So it means you see, OPC will be created for this. So web server support server security, because the newer firmware so many security functions. Then the configuration of SNMP SNMP is possible. It means SNMP is a communication protocol. So means which only support in 4.6. 4.0 cannot support. So if let's say that this, you see, this is your PLC. Let's say your PLC version 4.7 like this one around, right? But you are using TI 18, right? So it means only 4.6 you can choose. So no problem. Can download. Okay, can download, no problem. But yours is 4.2, but you choose here 4.6, then cannot download. Okay. Why? Because like we see the difference here, right? Okay, because you see, like this example, they say this is a 100K, unless not 100K. For example, this is a 150 kV. Okay, but 4.6 is only 100 kV. So it still can use. Still is inside there, right? So still can use, no problem. But here, this one, let's say is a 50 kV only. But you choose yours is a 100 kV, so which is not suitable. So that's why you can select the lower version. When you do programming, you can select the lower version, but cannot select the higher version. Okay? But if your PLC is 4.7, if your TI portal can go up to 4.7, then use 4.7. If cannot, then it's the next nearest number. Because for this, right, supposed to use because it's a new one, right? Because they need to use TI portal version 20. One. Okay, so now we are changing from 4.0 to 4.6. Okay. Okay, wait. So this above after 4.4. Okay, after 4.4, whenever you add a PLC project, I mean as well, because just now when you put 4.0, right, didn't pop up this correct. Straight away you go to the hardware, right? Okay, when you choose 4.6, okay, can you see? Got additional functions, okay, which is like some safety functions that is the protect the PLC configuration data from the TI portal project. Okay, so if you want to put password for your project file or the TI portal, you can put password. Okay, if no, okay, just remove this. Just uncheck this one. Yes. So means no need password. Okay. Okay. Next. Okay, only allow secure communication. Okay, this one. Remove. Okay. So normally the old one they call legacy. Okay, they already mentioned here some communication, any version below TI portal version 17. Okay, use legacy. If above 17 and above, so they have a new functions called secure communications. Okay, next. Okay, so full access, okay, no protection Okay. Actually, all these three, you can manually also can do the settings. You go to the hardware settings, you can do this. But version 17 and above, whenever you add 4.4 above, then you will have these features. Okay. All right. Finish. Okay. Now. Can open this. Yes. Okay. This one can close. Okay. So do you know how to read the IOs? Here the addressing. Okay. So you see so this PLC, right? say it's a digital input 8, digital output 6, DI8, DQ6, okay. Then the address, I address is the 0, Q address is the 0. So what is the meaning of this 0? This 0, it means, so they say what, DI8, right? So the 0 means is a input byte 0. So input byte 0, that is the meaning of the 0 there. Okay, on the address right here, right? Okay, this one. So it means, okay, they have how many inputs? 8 inputs, right? So, and if they tell you that is a byte 0, so it means I 0.0 until I 0.7. 8 inputs. So this is your inputs. Okay, good. Next, the output. So they say it's a DQ6. Okay, and the address there is the 0, right? It means it's a QB0. Output byte 0. So it means Q0.0, 6 only, right? It means so Q0.5. 6 output. But we know that 1 byte got 8 bits. So this 0.6 and 0.7, what happened? So these two become a memory that is inside the PLC. Okay, got it? The analog later we see. Okay? Okay, now what I want to do, actually these numbers you can change also. Okay, you can just double click, you can change it. Yeah, just double click and you see. The range is 0 to 1023. Okay, let's say you put a 5. For example, any number 5, enter. So if you put 5, okay, it means in the program you must use I 5.0 until I 5.7. So you cannot put here 5, but the program you use this one, okay, which is not safe. So you cannot, your program won't be run. Okay, change back to 0. Okay, now what I want to do is, okay, you close this. Good, okay. You see here, okay, this PLC, right, on the left hand side, I have some modules I can add. On the right hand side, right? You see what are the modules we can add here. Okay. In the center here, so this cover also can take out actually. The center cover. Yes. Yes. But it will be a little bit hard. Yeah. Yes. So there you can add modules like this. Wait, I show you. So these are analog output module, additional module, right? Oh, this is 16 digital input module. Which one can add at the side there. So later I'll show you. But if you want to add, you can all add. Okay. So if not enough, right, the I/O, because whenever we do a project, right, or whenever we want to control a machine, we need to know the number of input output we are using. Okay, so later I will tell you that how. Later we'll be doing some small projects. Okay, so so we can decide how many I/O we want to use, Then only we can decide what hardware we want to use. Because like this hardware, you see, on the left hand side is a communication module. But I don't have a communication module here. So communication modules, it means you click here, communication modules. Yes. So whatever module here, these modules only can be used. It means, okay, let's say you need a point-to-point interface. You click here, point-to-point, yes. You see, got RS232, RS485. So these are the communications, right? So this is the 9 pin, the small port. Okay. So let's say my device. There's one device. Okay, I want to take data from the device. Let's say the device don't support Ethernet, right? Then I have to choose this type of communications. Then I need to add here. Same for, let's say, some others, industrial remote control, all that. So whatever communication modules, all the communication module is on the left hand side. Okay. Then my PLC, okay, on the right hand side, click here. Okay, then okay, on the right hand side, what? Can close, the communication can close. Yes. Okay. So on the right hand side, all my DI, DQ, AI, AQ, and AIQ. All these modules are on the right hand side. Okay. In the middle is the board. So there is a signal board, which is a IOS. Okay. There's a communication board. You can add a communication board here, or there's a battery board. So these three boards in the center. Okay. So for example, you want to add this drive. Okay. So go to signal board. Okay. So my module is what? Just now no, sorry, the board. Yes. So it's an AQ, right? AQ1. Okay. So you go to AQ. They have only one model like AQ. Yes. AQ1. So only one model. You just click. Can you see? It shows blue color. So it means you only can add here. Okay. You just double click. Then what we can add? Yes. Then double click on the hardware. Okay. So if you want to know about this hardware, you go down here, because here is the information. Go down here, okay. This is a signal board, analog output like AQ is analog output. Just plug in terminal, the output is 0 plus minus 10 volt or 0 to 20 million. Configurable diagnostic, configurable substitute output value. Okay. So these are the description or the information of the module. Okay. So actually, what your company doing? What? Siemens?
I'm doing the control the spreader.
Spreader.
Yeah.
Okay. So it's using what?
Using what?
I mean the system they have spreader.
Yeah.
The system.
But the mainly use Siemens is doing for the plan side. The
Okay.
plan panel communicate with the spreader.
Oh, okay. Just to
So
data transfer.
yes, the spreader is using the EPAD PLC lah.
EPAD.
Yeah, EPAD with HMI display.
EPA.
EPEC.
Oh, EPAD. Okay.
EPAD got a few PLC.
It's a Schneider Modicon. White color, right?
I'm not sure.
Is it white color?
No, it's so many, and it's black, and it's silver.
Ah, okay.
Yeah.
So this system is controlling your machine. This impact system is controlling your machine.
Yes.
Then you using Siemens is for what?
For crank panel side.
Oh,
So it will communicate with the impact.
okay. So means this PLC will communicate to the impact lah. Using what communication protocol?
Stick can.
What?
Stick can.
Stick can.
You using the three cable only.
Oh,
Or I show you the drawing.
later. Okay. Okay. So your idea of this, you come for training for?
Want to know more about the
The
Siemens?
Siemens PLC lah.
Yeah, because I doing the impact right, I can do myself self-learning.
Okay.
But this one I cannot for self-learning because I think it is more complicated. Yeah.
Okay.
Because the impact is more direct one.
Okay.
Yeah, so this one not sure. My senior also not enough time to teach me more deeper.
More deeper lah. Okay. Alright. Because now I get idea so what to teach you. Okay. So because you need some this one. Because you need to know how to transfer data.
Yeah, sometimes I use this for do the simulation. I can give the command here and here will communicate with the spreader and the spreader will move. Then I can also give the status from the spreader and through this, and I can read from the laptop.
Oh. Okay. So you don't have any analog signals?
And yes, counter.
Counter.
Yeah, and we have the hour counter and twist lock counter.
Okay. So is it analog? No, right?
Analog.
Because analog means like the temperature or pressure or humidity.
Temperature no. Pressure also no. The analog I think no.
No, okay. Because analog is more to these two signal only. 0 to 10 volt or 0 to 20 milliamps. Okay. For that only we add your one. Never mind. Okay, but never mind. You have your wiring diagram, right? Okay. Later you can show me so I can get some idea then. Okay. Alright. Then at the side here you can add a DI mode. Sorry. This is signal board, right? Okay, you off the signal board. Then now we want to add this module, like for example. This module is a digital input. DI is a 16 DI. Okay, what is the part number? So you can see. Okay, this one, right? So this is a what? A digital input module, configurable input delay, plug-in terminal blocks. Okay. You can double click or you can drag and put it also there. Okay. So now I add my new one now. Now what you do, you open this. Yes. So now you see the DI I add right, it become 8 and 9. Normally automatically it will be like a bigger number lah. Okay. Actually we can change it because you see the input we only use 0, which is this one, right? So we still have 1, 2, 3 all that. So we can use 1. So you just double click here, put 1, enter. Yes, so automatically become 1 and 2. Okay, so it means it's a DI 16, right? DI 16. So it shows 1 and 2. Okay. So it's 0I 1.0 until I 1.7. Right? 8. Okay. Then I 2.0 until I 2.7. Another 8. So these are the addresses we can use. For the analog, so here's the analog, right? Now we see how the analog. So it's the AI2, correct? It's a 2 input. So they say 64 to 67, right? So means got 4 byte. 64, 5, 6, 7. Okay. So how to read? Because we need to know analog is IW. Like I said, right? This is a bit I0.0, right? IW 64. Okay. Then next one is the IW 66. So these are the address for analog. This is how we need to read the address. Okay. Why? Because word inside have 2 bytes, right? So it means IB64 plus IB65. Means that is inside this word. Same goes for here. It's a IB66 plus IB67. Okay. So that's why it shows that I'm using the byte 64 until 67. So it's showing that this number is showing this. Okay, this analog input module, this analog input is using from byte 64 until 67. So next available byte is 68. Just giving you information. Okay, but how to read the analog? This is the way IW. Okay. For output is the one we add is a AQ, right? AQ1, which is 8081. Yes. So it means this is the analog out. Analog is a QW 80. So why here 8081? Because inside QW80 is a QB80 plus QB81. Okay. So this is the addressing format. This is how we see the addresses. Okay, good. Save first. Okay. So, but what we do, we don't need this cursor. Okay. Okay. Just remove it. Okay, delete. Just right click here. Okay, delete. Delete, yes. Because we're not going to use, right? So we can delete that. Then out the DI16 also. Delete. Okay, save. Okay, because we're going to do a simple projects only, right? So no need additional inputs. Okay. Now, so once we done this one, we need to give then we can go for the programming part. So the first always is the hardware. Whenever we do project, we do the hardware first, then only the programming part. When you go to programming, go to PLC tag, show all tag. Yes. So this is the tag table. So we can click all the tagging here. So just click a simple tag, that is start, stop, then a motor. Start is a I0.0 is correct. Stop is it. Then the motor is output, right? So you can change it. Q0.0. Yes, you can type here also. Yes. Okay, good. Save. Then program blocks. So by default, you will get the main OB1. Okay, and you can add some other blocks as well. Okay, open main OB1. Okay. So this is where the what? All the symbols are, right? Normally open, normally close, the output, the branch open, branch close. Okay, but normally by default you will have normally open, normally close, the output, the branch open, close, and also this empty box. The rest normally you won't have. This one my previous training, so the student just added. So you can manually add also. Which one you commonly use, right? You can just put it on top. So no need to find here. Okay? Because all the instructions are here. Okay? Now put normally open. Drag and drop also can, or you click here. Just you double click this. Also okay. Okay. Let's say you put here the start. So you can type the name, or you can type the address also can. Let's say the output, the motor Q0.0. Type Q0.0. Yes. This is okay. Okay. So when I start, motor. Let's say this is a push button. When I release, motor off. Okay. Then you click here. Here is. Then you add a branch. Okay, normally open. Then close branch. Yes. Then here add the motor. Yes. So when I start motor on, I'm using a latching method or holding, because this is a push button. So I use back the motor here, and then here I can put a normally close. Stop. Yes. Okay. Once done, just save. So now what you do, you just click on here. Just select the PLC. Here you can click download. Okay. So can you see here? I cannot communicate, right? I think the Start search means the cable is connected. Okay, look. Okay, so it shows that inside there got so many programs, right? But it shows the CPU contain changes that cannot be automatically synchronized. Okay, you know why? Because when I click download, the software will go online with the PLC. So it means you go online. So when you go online, you see inside there got some program. Then your laptop also got some program. So which cannot be synchronized, of course, because this is different project, right? So that's why it shows that CPU contain changes that cannot be synchronized. So I don't want to synchronize actually. So continue without synchronization. Okay, now here. You see protection, of course because we haven't do any password setting, right? So no protection. So okay, this one means it's a warning. Okay, so can you see? So whenever you click download, the software will do a compilation. So it's give you a warning. The warning is, you can see from the rack 0, PLC 1. So does not contain a protection level. So means we don't have a password protect. Okay, no problem. Then you click on the different modules. This is what just now I think I said about this. Yes. So you see online article, offline article, both the part number is same. But the firmware online is 4.7, which is my PLC. My TIA portal is 4.6. But still it's just a warning only, not an error. If it is error, it will show the red cross mark. Okay, so it means you still can download, but let's say maybe 4.7, and this one maybe under 50 KB, so you can't use that much of memory. Okay, so this is not an issue. Go down. Okay, then stop the module. Yes, you click here. Because why I need to stop? Because I'm downloading totally a new project, so I need to stop. Okay, so I need to choose this here. Stop. So why actually I need to stop? Whenever I download a new project into a PLC, I need to stop because it's not totally a new file for the PLC. Okay. That is number one. Number two is whenever I stop the PLC, what happens? Do you know what happens when I stop the PLC?
All the configuration will
Not the configuration actually. The outputs. Output. Okay, why? Because you see how the PLC works. PLC is okay. You have a logic, right? Ladder or whatever logic. So PLC will scan, okay, up, down, scanning. Okay, so it scan, it give the outputs. So can I erase this? Okay. But sometimes people don't get it. Why I need to stop, right? Why I need to stop? And stop means what happened, okay? Because stop can damage your machine. Can damage the system, even can injure someone. Okay, so why? Okay, you see, this is the like logic. Okay, I start motor, then stop. Okay, so how the PLC work? PLC will scan here, then go down. Okay, so it keep on scanning lah, but in milliseconds, actually very small, very fast scanning. Okay, and so the scanning, so the PLC will do the scanning when it is in run mode. So when you go to stop mode, PLC will stop the scanning. So what happens? Let's say there's a sensor here, and sensor is on. Let's say like the blower lah, for example lah, the blower. So sensor on, blower will on. So when I put the stop, even though the sensor is still on, but my PLC is not scanning now, so the blower won't work. So that's why all the output is cut off. So that's why whenever you want to download something, if it asks you to stop all, you must make sure is it safe or not to stop the PLC. If not safe, okay, you do whatever necessary things to do, make sure that it is safe. Then only you stop the PLC. Okay, but this one is not giving you just by the message lah. I mean the message not showing the message like okay, depending on this one, okay, it's not showing how dangerous. But if it is in LM PLC or LM or say Mitsubishi or not, even the older Siemens, it will show the message. Actually, especially the LM PLC, it will show okay, the downloading is hazardous, so it might damage your system. So please make sure the system is actually something that is good or something, so we can stop the machine. Something that give you a message, you know. Then that's the one thing, the first thing. Okay, stop. Okay, load. Now we load. So it's going to load the configuration. Right? So going to load your configuration. Okay, wait up. Click here. Okay, so the module PLC can be started. Okay, this one also must be careful when you want to start. The same thing. So let's say the sensor is already energized, right? So means the signal is already here, but your output is not working because it is stopped. So the moment you start the PLC, run the PLC, suddenly your blower will come. So this one also must be make sure whenever very simple, whenever you work with the machine, right? Whenever PLC stop and run, so you make sure which one is it safe or not. Stop. Okay? Because I know one of my participants, because of this PLC thing, he broke his bone here because of this. I think this one got some vacuum, and need to know that they do the Mosaic, the big Mosaic one. So that company is doing that. So they have a vacuum which is need to go down, and so when it's off, when it's in stop mode, means it's go down because there's no pressure. I think they're using hydraulic, so it will be at the bottom. So when they start, okay, then only going up everything. So what happened at one time? So it go halfway and stuck on the sensor is not moving. Didn't detect. So it's halfway stop. So what happened? He tell his guy to press the stop button. So means if it stop button means no. He asks you to put in standby mode. So means in standby mode, this when the sensor detect, it's supposed to go up. Okay, so it didn't go and put a standby mode. It go to put in stop. Stop mode means it is to go down. So it is will be go down. It is like a home position. So it's really go and adjust the sensor. So when the sensor, because sensor detect, send to PLC. Right? PLC will control your output. So what happened? The PLC off the output. So what happened? The hydraulic go down. So anyway, then hit here. Then what? Because that is a new machine. Then after that, we contacted the machine maker. Then they put some safety sensors. So whenever the machine is running or suddenly start or something, if they put the end, all the system go to cut off. So the hydraulic oil will go up. Something like that. So very important. This one safety. Okay, finish. Okay. Then you can minimize this. Okay, so I think you done on something like this before? Done before. Okay. Start with the basic. Of course, I need to start with the basic later on. Okay. So you let me know which one you are done before. You let me know. So you can go to other parts. Okay. Okay. Then you go to monitor. Okay. Of course, now the start button, stop button cannot work because there's no buttons. Each button is something. Okay. But later on, because later we can use this. Later we can use this one. This power up. This okay. Then, so now, if now is it got error? No error. Okay, why? No error. We know first. We need to know what is the error before. The error is because the project, the file inside the PLC, the configuration is they have additional cards, right? Just now because when you upload, you see got additional 2 cards. Okay. So this project, I don't have any cards. So whenever I download a new project, you download the 2 things. One is the configuration, which is my device configuration. Second is the block. Okay, so the device configuration download ready, so no error. Now, you right click here, modify to what? Cannot work. Of course lah. Okay, why? Because this is a physical button. Okay. What mean by physical button? Of course lah, it's must have a input, right? But why? Because you remember just now our input is DI8 0, right? The byte 0. So it means 0.0 until I0.7 is a physical. Anything other than this, you can modify to 1. Okay, we add one more. You go offline. Then go offline here also can. And off the monitor also can. Okay. Let's say you add one more start button. You click here. Yes. No. Just add a branch. Yeah. Put normally open. Then you can close the branch. You can drag also can. Yeah. Or you can click this one also can. Okay. So you just put, for example, I 1.0. Okay. So it automatically become tag 1 line, right? Because why? Because this tag is not in my PLC tags. So it become a tag 1 line. Now you just download. Okay, look.
didn't ask you to stop, right? Because now, because the hardware all down already, right? So now you only the programming. Okay. Then can close. Then you click monitor. You right click this. Yeah. Modify to one. Okay, see? This address can on. This address cannot on. Okay, so that is the reason, because this address is physically on my hardware. The 0.0 until 0.7. This address is not there in the hardware. So that's why. Okay, good. Okay. Okay, you right, because so what happened? This one become like a similar to a memory already. Means it's internal inside the PLC. Okay, off. So if a physical button, so you want to turn on, you must use a watch or force table. Yes. Go to force table. Here you key in I 0.0. Then I 0.1. You can make it smaller. Sorry. Beside floating window, yes. Then this one can make it small. Yes. Okay, I just want to see this tool. Okay, that's nice. Now, you right click here. Force, okay, force to 1. Okay, wait. So the forcing, can you see? It shows that warning also lah. Okay, why? Because if you force the start button, it can energize the motor, right? Supposed to energize the motor lah. So make sure is it safe if you are doing the forcing function. Okay, yes. On. Okay. So if there's no, so at the same time, can you see the maintenance lamp is on? So whenever you do forcing, the maintenance lamp is on. Okay, so it means what? Force. Okay, when we do force, okay, like this lah. So whenever the input is not connected, but you want to test your output is working or not, right? Then you can do this force function. Okay, or sometimes some sensor, for example, like this. Let's say this sensor is something like, let's say example, this door, right? So whenever I close the door, there is a sensor. When the sensor detect, let's say it's it will on the exhaust fan, for example. So the sensor, this is the low exhaust fan. Now let's say the sensor is spoiled already. Okay, sensor is spoiled already. So what happens whenever you close, of course the sensor will detect. Right. So in that case, what we can do? We manually close, then we can manually force the sensor so that the exhaust fan is on, for example. Then once you change the sensor, then you just remove the force. Or sometimes what happens, some people they if let's say they are not confident about the software, they are not very really familiar with the software, what they do the force in the wiring, they bypass. They just take one cable, bypass to the sensor, so that the sensor is like how to say, like manually on the sensor lah. So until the sensor is changed. So you can use bypass or you can use this. Okay, force function. Another thing is when they use the force function is when they do commissioning. Let's say when you buy a machine, right? So you buy a machine, okay, you order, so they come here and fix the machine. So during they fix the machine, do the cabling, everything. During that time, the PLC normally will be empty only. No program is set. Right? So they will do this commissioning. So during commissioning, they can use the force function to make sure, okay, the motor here, as I say, I put motor 1 example lah. So when I force, I make sure see motor 1 is on. Then I make sure at the machine also motor 1 is on. The wiring is okay or not. Maybe the settings is correct or not. All that you can use this force function. Okay, good. Okay. So you force to 0. Okay. Now you force the stop button. Right click, force to 1. Then force to 0 again, because it's like on then off. Oh, right. So if the force is still there, my physical input cannot override the value. So now it's become like force to 0, right? Means the value of start is now 0. So if I press the push button, the signal that is going in, right, cannot override this value 0 until I need to remove the force function. Okay, so you need to remove the force function. No need. Just right click on the any force there, go to force, stop forcing. So now in this case, now by input the push button can energize the start button. Okay, good. Any question until here? So far okay, So what we do, change to this one. So easy to test now. Press button. Okay, so this one I have same 1 2 1 2 same thing. Then I have 3 push button, 3 selector switches. Okay, then 6 lamps. So if you want to do any projects, right, easy to test. Okay, so this is the power supply. Power supply terminal block. So later is 24 volts supply here. And from here I will connect it to here. Power supplies. Right? Then all these push button I connected to here. Input 0 to input 5, the 6 inputs. From here I already connected here. Then from here I already connected to the inputs. Then here is the output. From here I connect here. Then this one go to the lamps. I designed something like our machine, right? Why not? This is our field device. This is inside the panel. So normally this one will go to the terminal block. From the terminal block then go here, right? So just need to power up this. Your background is electronic or electronics?
And the first is electronic, but the uni forced us to change to electrical.
Oh, right.
Because they say the electrical is more easy to find the job lah.
Oh.
In general, they said like this lah.
Oh,
Yeah.
electronics. Okay. Which university?
UMP.
UMP.
Yeah.
Ah, okay. So you graduate? When you graduate? I mean, when you graduate?
From when last year.
Oh, last year.
Yeah.
Okay, okay. Because I know my friend last time, he did his degree there also.
Same course.
No, okay. Same like you. So now you see this one also same model, you know. Actually this project the same, the whole project you can download here as well. Yes, no problem. This output will be so just download it. The PLC, choose the PLC, yes. Then we can because the thing is not disconnected, so you go offline first. Continue with the okay, same thing lah just now. Because first time you downloading, right? Need to stop on. This two. So this one can you see blinking, right? Because why? Now I download only the base. So this one is not counted with it. That's why. So because it's two different cases. This one is supposed to be 4 times. Just change this to okay, you go for monitor. Other one can close to me. Yes. Do you need to mouse? Use the mouse. Yeah, easier. I thought no, only I put mouse. I think it's helpful. Okay. now you press this button, then you can see the lamp. Yes. Press the release, that is off, right? So that's why we do the latching. Right? That's why we do the latching. Because why? This is a push button. Okay. So why? Because you see, generally, okay, PLC is developed from what? PLC is actually developed from relay systems, right? Relay systems, so it means, example, earlier before PLC, they were using like this. Okay, let's say this is 24 volt. They use a normally open push button. Then they want to on a lamp, right? So this is 24 volt, this is 0 volt. So because switches is just pass the signal. Lamp is must have a 0 positive negative, right? So what happens? The lamp will energize. If lamp will on or on. So if I release the push button, lamp will off. So in that case, what they do? They put a relay. So you know relay, right? Relay, okay, relay will have a coil, right? Then they use the relay contact, normally open contact, they connect back like this. So when they press this button, push button, the 24 volt go in, energize the relay, then another 24 go and loop here. If they release, still the relay is energized because of this connection. Same like we do here, right? So this is used our output, that the same address used as a contact, or the open contact. Then in actual, we use another contact from the relay. Now I'm on the lamp. With the same relay, because relay, right? Or 2 contact, 1 contact, 4 contacts. So now if I want to off, I put a normally close button, push button to remove. So this is the before PLC. Now when they come PLC, they remove the relay. Because my PLC can become a relay already now. Okay? So that's why they use the same name. Normally open, normally closed. This is called coil. But in TI portal, they call assignment. You bring the mouse here. Go to the output. Yes. So they call assignment in TI portal. But if you see like older PLCs, they call coil. Same name like the relay. So now whatever they don't need this. They just connect 2 push buttons, like normally open button. One is going to the lamp, then it can on. Now you press this button, this lamp can on. Press this button, lamp can off. Then you want to put a timer, you can put a timer. Everything, whatever you want to do, you can do. So that is the PLC. Okay, because I have done a few panels are like this. They have a panel all relay system. Then I take out all the relays, put the PLC, then do some more area, can control your system. Okay, good. Any question? What? Okay. Now what you do? You minimize this. Go offline. This one take out no need. Can delete. Okay, we add a timer. Okay, so you can use the same network or different network also. So let's say use the same network, like click here, add a branch. Okay, but is normally open. Okay, timer. So for this one put the motor. timer operation. So timer got so many timers now. So like this, the blue color means is a block type. It's a function block type. Okay. Then this is a like a logic lah here. Okay. Means this one means it's a block. Okay. So let's say normal, very common one is a TON. Okay, you take the TON, put it here. So like I said, it's a function block, right? So if you call the function block as a single instance, the function block saves its data in its own instance data block. Means if you save its data inside the data block lah, okay, later we go deeper on this. Just put a name, timer 1. So this timer will have a in, PT, Q, ET. It is the input lah. PT is the preset timer. How many seconds you want? ET is the elapsed time, the timer run. Q is the output. Okay, let's say I want to put 10 seconds. So just put 10S. But must put S the S line. If you put seconds, S line. If you want to put minute, can go up to 23 days, if not mistaken, the value. 23 days, but later I will show you how I know all this 23 days. Okay. Now, you see, start, motor on, then I use the motor contact, right, the interlock, to energize the timer. Then after the timer, let's say I want to cut off my motor. Okay. I have two ways. The first one is you click here, put normally close here. Normally close. Okay, never mind. Don't delete. If you choose wrongly, no problem. Just double click, you can change it. Yes. Okay. Then put here the name timer 1. Dot Q. Yes. Means I am choosing the block. The timer 1 dot Q is the output one. Okay. Okay. You save, download and test. This one actually, you don't need to close this, you bring it down. Yes. No, you click here. No, the black color. You double click again, yeah. Okay, just pull it down. Yes. All the way down. Okay. Because when you click this, it keep on coming down. Okay. Now you press start and monitor, see what happens. Right. Yes. Now, how it off? But you can see the timer right very fast. Okay, so actually what happens is when you put on timer and adjust, after the timer give the output is the Q. We on and I cut off here. But you can see the timer on, right? So for that, what I can do, so there's one way I'm using here. Another way is, can you go offline? You can just click this. We will remove this, delete this. You click here, you put the output. Yes. Then you add a memory M0.0. because no, we didn't assign the tag right in the tag table, right? So you can right click the tag tool, can rename. So this memory I want is to use to off the motor. So you just put motor off. Okay, change. Yes. Then later I can use this to cut off here, like same like the timer, but I don't want to use now. I want to observe the timer first. Okay, download. Okay, now you press the start button. Now you can see the output is on, right? Because earlier is the output on, I said we cut off. That's why. So this is how the timer works. The timer is when I get the input, I start to count. Once I reach my set point, I give out. Okay, you press the stop button. Stop button, second button. So if the input off, timer also reset, output also off. Correct. So that is the function of this timer. So this is how you can learn the functions here. Okay. So some functions. Okay. Go to instruction. Let's say you want to do some functions like then timer. Right. Example. So you want to know how the timer works. Okay. Because programming is very simple. Programming is if you have all these are instructions. Okay. Normally open, normally close. Coil is the standard lah. After this, timer, set, reset, all these are what they call is functions or they call instructions. PLC programming is very simple. That is, you need to know how to use those functions. That's all. Or if you're doing troubleshooting, suddenly you see some functions. To do the troubleshooting, you need to know how the function work. Right. Let's say for example, if you want to troubleshoot this motor, right? So this motor is here, right? Then I have a timer. So I need to know how the timer works. Right. Then only I can troubleshoot this motor. So if any functions is new, so you just bring the mouse here. Just wait. Okay, so it will open like this. So TON means timer on. Delay the setting of Q output by program time PT. Okay, sometimes this language, right, you don't understand. Correct? This is the what they call the software language lah. But when you used to it already, then one time you study, you can understand it. Okay, it's not like normal English. It's like delay the setting of Q output by program PT. So you don't understand also. So what we can do is go to again. Put again the mouse. You wait. Okay, you click on the yes. So it will open up the information system, which is they call what? The help function. Okay. So the full explanation is here, the full description. Okay, blah 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 blah. They said the thing are very simple. They said, okay, when the input is on, timer will start to come. Then once the timer reach your PT, then output is on. That's all. Okay. Go down. The most important one is the go down. Okay, go down. Then they will tell you what is the input. Input. In means it's a start input, PT means is the duration of the delay. Q is the output, that is the when the time PT expired. ET is the current time value. Then here they put the data type as well. You see, in is the boolean, out is the boolean. Means that's why it's a line, right? So because this line means it's a boolean. Okay? Then PT is the time. That's why we key in 10 seconds. Then ET also is the time. Go down. So here they explain using the graph, okay? Very simple actually, and easy to understand. So the PT is my set point, okay? This is my set point, and this is my ET, okay? Then this is the input, okay? So when the input is on, okay, then it start to count. Once I reach the PT, the Q will on. Okay, the output will on, it stay on. When the PT becomes 0, my output off. Then when the PT start to count, halfway off, nothing will happen. Then again, when the PT start to count until I reach my set point, then the output will. Then when the is off, the output is off. That's the thing lah. And here they give the example. Okay, example. Actually, this software is very good because you know why they give example. You go down, then they will explain the example how it works. So any functions you suddenly see some function and you don't understand, you can use this information system. Okay, good. Close. Now, what I want to start motor on. Okay, I want to put the motor off here. Normally close. The motor off. The memory M0.0. Normally close. Okay, download. Now you press that. Okay, good. Now, for example, you want to on second motor. Okay, go offline. Click here. So you see start motor on. Okay, then after this motor timer, after this timer, I on this memory, right? And I use this memory here. So to off this motor, right, I can use like this also can, or previously the timer 1Q, right, that one also can. To cut off this motor, right? Okay. But okay, like this for example. So can use timer 1.q, or I can create a memory. I can use the memory also. Means this or this line. If it is one motor, okay. If it is one motor, actually I don't need this. Straight away timer 1q can. But if I'm doing something like this, means from this memory I want to on another motor, maybe motor number 2. I want to do this, then I cannot use this. So I need to create a memory. I use this memory here to off this motor. I use the same memory here to on motor number 2. Because then I need to dash that, right? Motor 2. Because this memory, because the moment I on, here also on, right? Then this motor will off, right? Then this motor will off here. Timer will reset. Timer reset, this memory will become off. So this memory like on, off again. So that's why, so it become like a push button. So that's why I put latch in here. Okay, later we can try here also. But why the timer 1Q cannot? Because timer 1Q is very fast. So I cannot use here timer 1Q. Okay, we try this, then only we can understand. Okay, because it's very fast here. Okay, so what you do? Here you put normally open. Yes, you add the timer 1.q. No, timer 1.q. Yes. Still here. Never mind. You remove. Double click. Just erase everything. You type again. Timer 1.q. The comma is there. Oh. Okay. Why not? Timer space 1, double click here, or you just click here, just key, yeah, timer 1, Q, dot Q, yes, okay, right, then you add another motor, you put Q0.1, one output, you add one output, yes, Q0.1. Then you do the holding. You must put the branch. Undo this. Then here you add the stop button. You can use the same stop button. Zero point, yeah, stop. came, then you add here normally close timer 1.q, same one. Yes. So it means I'm using the timer 1 to energize motor number 2. Okay, so it means I start motor on, motor run, timer. After the timer, the Q will energize, correct? So I use the Q to cut off the motor. At the same time, I use this Q to energize motor number 2. Okay, not this one. I'm using this Q. Actually, both are same thing only. Okay, but never mind. We download and test. You can see big difference here. Okay, press the start button. See what happens. Is it motor number 2 is on? No, right?
No.
Okay, why? It's supposed to on, right? According to the logic, it's supposed to be on. Because see here, let's say I'm using this right? Timer 1. So I start motor on, then the motor will energize, the timer will start to run, right? Then the Q will on. Okay? Means timer finish, timer will give the output at the Q. So here also on, here also on. Okay? Then so supposed to on motor number 2. Correct. But why? Because it's too fast. The scanning, right? The scanning is very fast. So it means actually, so you need to know how the scanning work. Okay? So let's say I don't use the M0 controller here. So this is normally close. Okay, we don't care about this. Okay, let's say I'm not using that here. So when I press start, current flow, motor on, dash is correct. Then here motor on and then I press off. So PLC keep on scanning, timer also running. After 10 seconds, the Q will on, correct? The Q on. Here on, correct? Here also will cut off. Okay? But my PLC, what my PLC do? PLC will scan this first. Okay, when the PLC scan this and see this one is already open already, right? So it will cut off my motor. Okay. Then when cut off my motor, so here will off, right? So that when the PLC finish this line, okay, it will go to this line to scan. So it's still on, right? But it won't give you the signal because my PLC haven't scanned this program. Okay, so PLC go here and scan. You see motor off already. Okay, so what happens? It will off this. So timer will reset. When timer reset, the Q will go off. So here will off, here become normally closed back. So the moment PLC come here, the timer is not on. So that's why the motor 2 cannot energize. So that's why I cannot use this. So So instead of using this, what I do, I take out this, I use the M0.0, a memory. Okay. Now the same thing. When I start, the motor on. Okay. H here motor on. Okay. After the timer output, the cube will energize this memory. Okay. So when energize this memory, here cut off. Okay, because you see now PLC continuously scanning, right? Okay, when it come here and scan the cube, so it will energize the motor and memory. Then it will go here first. Scan this first. So now I scan here, I can energize motor number 2. Then I go here, I see motor off already. Okay, memory open already, right? Now I cut off this and this one off. Then my PLC come here and scan. Now only reset the timer. Then only the output will off.
The scanning will not be accordingly the sequence.
Yeah, 1, 2, 3, 1, 2, 3. But earlier one the Q, right? I know why. Okay, because you know why? Because earlier one Q is the timer output. Okay, so because it's not a memory, it's not like this one complete, then only come here, right now. Because that's why if I put like this, means this I can 100% know this one finished, then only I go here. If I don't use this, I just use the Q, whatever is, because this one is running on seconds, right? Timer. So just keep on turning, keep on scanning. The moment when this one is energized, the Q is energized, that's it. At that particular moment, I already passed this. Go back up again, right? So what happened? I will read the output. So means there's a very fast. Okay? Unless if you want to use the timer 1Q, right? Can. What do? You take this and put it down. Then your motor 2 can work. You try and see. Maybe we can try that. Then you can understand. Because there's very small timing delay between here to here, actually. That's why sometimes you see if they using timer, this timer want to just off the particular input, right? Then you can use the timer 1Q. But this timer, let's say I want to off something, then I want to on something, do multiple job, right? Then you need to take the memory. The output store into memory value. So the memory value can keep the data for a few seconds before I cut off. Okay, good.
Only for timer will.
Yeah, timer normally. Because you know why? Because there's a clash between two timers. One is this timer running. Another timing is the scanning time. But if you take out this, if you put below this, then the motor 2 can work. You try and see. You go offline. Okay, what you do, you just highlight this whole thing. Yeah. Inside this one, make sure just highlight. You click here, click here, like you are selecting that normal click, right? Yeah, normal. Then just highlight this. Yes. This. Okay. Until the motor is okay. Then you just cut. Okay. Go down. Let's say you paste it. Yes. Okay. Now you download this and test. see, the timing is very sensitive here, especially this time. Okay, go offline. We put back the timer. You go up. First, you create one line first here. Yeah. You put one line here. Then only you can paste it. Yes. You go down. Then you just same as that just now. Just highlight. Yes. Cut. Yes. Paste here. Okay. Now go down. Instead of using the timer cube, I use the memory. Here. Okay. Now we test this. Press stop first. Second, okay. Now you press start again. Okay. Still cannot, right? Because of this you need to remove this. Because this one and this one there's a small delay. Take out this. Download it. But the only annoying part when we do, when you learning every time you download. Now we press that. Okay. So you see how how the scanning time affect our program. Okay, good.
So the timer is must use the.
So the conclusion is timer must use memory something like this. So make our life easier.
Okay.
Okay, good. Okay, any question until here?
Understand.
Can Oh yeah. So whatever you done, just save. Just save. Okay. Then you go for your break. And after the lunch, you continue lah. Continue with other function and you try to do some projects. Okay.
Sure. So my computer, I just left here.
Nobody will come to do this. Because normally I will stay here.
Okay.
okay, ah? How many nice PLC we have? One, two, oh, only two.
No, same thing. Both are same thing.
Uh-huh.
That is a nice brand. This is a Panasonic.
We had one, right? That one is the big one. That one also Panasonic, right? Illa.
Which one? The big one? Telemechanic.
The Telemechanic.
Yeah.
Telemechanic also. No, Telemechanic is different, right? Schneider. அது வேலை செய்யறது தானே. பண்ணிட்டேன். That 1200 PLC, what do you want me to do?
1200.
அவங்க கெடுக்குச்சு. அது ரிப்பேர் பண்ணுங்க. நான் கிட்ட அந்த
Oh, the hours, huh? Yeah, we check and see whether we can. Which one cannot power up? Cannot.
It still works lah. Yeah, last time my father would try this before.
No, that one is power short. So it's what version 11? What's it? Oh, I put fault right now.
Yeah.
The one is the power. It's working, but it always go to the error. Error. Cannot download, cannot upgrade the program.
Oh, no, okay, from there. Okay.
Can we see your phone? So I can get some idea.
You need to give me some time because I need to access my company's server.
Ah, okay, yeah.
You need some.
No problem. We do that.
Okay. Because the IT log
Yeah, of course.
log and everything.
Yeah.
Yeah.
That's the problem because PLC, because when you involve in automation, need a lot of software, So, and IT log, that one is a very problem. So sometimes you just want to back up only, like one day only want to use the software, but you need to buy the software because of this IT.
Yes.
If no means you just can download from the internet and install just for one day use. After that, okay.
one is the programming to receive the when using the CAN control. Yeah, this one they create themselves. Actually, they do it, they create themselves. Changing the file. So means you're using the CAN. Actually, the protocol they use what they call CAN bus. So CAN bus. So between the Wango to be this.
This is one of the example lah.
Oh.
The one examples.
So
If this is using a Siemens 1200. This
just now the what the wiring diagram is the Wango.
Yeah.
Oh, okay. So the what the model you see the other one EPAC, right?
Yeah, effect we use the codices
E E
EPEC.
EPEC.
Yeah.
Okay. Come with the okay. Okay, 32702. It's a grey color, right? That is a
Yeah, in the small one and the rectangular one.
okay. I never used this before. First time I see. So for that you are using codices.
Yeah.
So in codices what language you use?
Same like the Siemens is very simple only lah. Use the function
You
block.
are using function block.
Yeah, and
So means
all-
using ladder lah.
Yeah.
Ladder lah.
Then
Codices.
What means my level is shown like.
Ladder just now we do similar one we do like.
I think just now I showed to you is called the level also.
Yeah.
Ah, same.
Okay. Because that ladder same like Siemens also. Because codices is like it's a programming software for like PLC, like how to say. Okay, so like Siemens, right? Siemens they have their own operating system inside this PLC, right? So Siemens they are using Siemens system. So you need to use the the TI portal to program it. Okay. So effect I never used before, but codices I know. So the Wango what do you use the codices also?
Yeah.
Okay. Because Wango back off PLC and EPAC. I'm not sure about this, but I know Wango and back off. Okay. Both the operating system they using is a window. Like this they are using Siemens. So the back off Wango they using what they call it, Windows operating system. So that's why you can use codices to program it. Or even like Wango they have their own software. Like back off they have their own software. So you can use that software, they call WinCC. You can use that software to program, or you can use codices to do the program.
Not like Siemens is more to the specific.
Yes,
software.
it's a specific software. Like some others, because why? There's a two different things. Okay, this one normally they call PLC, programmable logic controller, but in like Wango or like back off, I think this one also same other impact. They call IPC, industrial PC. So it's running on Windows. So that's why they can use the codices to program. So inside codices actually got 6 types of language. One of that is ladder. So inside codices, because codices is the one like have all the language. Siemens okay, they have their own language. Like Omron they have their own language. So normally all all the languages ladder lah we use. Okay, so the one we used just now, like a line one. Okay, then number 2 is the structure text. Okay, structure text, or we call SCM. Okay, both are same. Both are, you know how the program is. The program is something like
All text.
if, then, else,
Yeah, all
the
text.
text one, right? So common is this one common lah. I think in core disease also they call structure text. This one most of the PLC. Okay, I put most of PLC. Ladder is all PLC. It means if let's say I have a product, let's say this is the one Panasonic one. Let's say I want to sell this as a PLC, must support ladder. If this one don't support ladder, I cannot sell this as a PLC. So that's why all the PLC they use a ladder. Then this one most PLC they call structured text. SCL, yes. Siemens they call SCL. But both are same thing only. They call this one structured text. This one called structured control language. Both are same thing. Then we have another one called instruction list, IL or STL. Okay, so instruction list or statement list. Okay, so this one Siemens they call this. Some other PLCs they call other PLC. Okay, other PLC they call instruction list. This one will be like a list. In Siemens mostly is common in the 300, S7-1200. They do like this program. For this right, they do it this way. A means normally open, right? So they put A is I0.0. Then AM is I0.1. And equal is output, right? Q0.1. Something like this, like a list. Okay. Then they have function block diagram, FBD program. A function block diagram is like a block. Okay. Maybe I can show you how it works. So first I do this one. Okay. Function block diagram. Function block diagram is another language. Later I draw for you. Okay. How it looks. Okay. Then it's like a block diagram. They have a block by block. Okay. In Siemens also they have. Most of the PLC they have this. Okay. Then number 5 is called SFC. It's a sequential function chart. Okay, it's like a flow chart. Okay, sequential function chart. Then ladder, structure text, STL, FPD, SFC. Then what else? Yeah, this one. This is the most common. So in code this is you can use all this type of program. In code this, okay. But in Siemens, let's say Siemens they have ladder, SCL, STL, and FBD. In Siemens, all the model they support all this. Okay, but you cannot use STL for 1002. 1002 only support ladder, SCL, function block. If 1005 or 300 can support ladder, SCL, STL, function ladder. Okay. In Omron, some of the Omron model they have ladder. They call structure tags. Then that's all. It's two. Okay. Then in Anabody, they have ladder, structure tags, FPD, SSC. They don't have STL. So different PLC, different way. Okay. Then so then but this one like Wago, the back off, I think then the impact also same lah. Because these all using cold disease type. So you can use all these type of object. Okay. Now we see, I show you how it looks in ladder, everything. I do simple program. Start stop. Okay. I erase this one.
Okay.
Let's say in ladder, okay. Start. One output, okay, motor. This is stop. Okay. This is ladder lah, right? Okay. In the structure tags, okay, so you can put like this. There's a two-way in structure tag. If you're using if lah, right? If start off, this is off function, right? Moto and not, because normally it was right, and not stop. Then motor is true. Else motor is false. Then you must end if. Okay. So this one is a structure text or SCL, right? Okay. You can do this way or you can do this way also. This is do like this. Put the output straight away. Put the output here. The motor is equal to start of motor and not stop. This is okay. It's the same thing. Okay. Then in this is again, right? Then another one is what? FPD. Okay. So FPD function block diagram. Function block diagram, okay, this same start to stop. Okay, so they will have like a block. They put off function. Okay. Means this is off function, right? Okay. Then they take the output. Then they will have I just put the name like AND function. Okay. Then the output put equal to the output. So see. So all is start on motor, right? Okay. So one of these is on. I give the signal here. Here I put AND. But my stop button is a normally closed, right? So they sometimes invert, right? So this is an invert. No, this is stop. So you invert the value. Okay, so it becomes an AND, and output is the motor.
Based on I think the code program is some more like.
That is that is using controller lah.
Yeah.
Okay, because ladder also is like mix of ladder and controller. Okay, then statement list. Statement list very simple. So STL or IL lah. Okay. So this one is they put okay. This is normally open, right? Normally open, but it's an OR function, right? So they put it okay. A and open bracket or close bracket. So A means it's normally open. So open bracket, okay. They will put start or auto. Something like this. Then AN is the stop, then equal, or sometimes we put equal or out. Okay, depend on the PLCs lah, right? This one is a statement list or instruction list. Simple, right? Then the last one is the SFC. Okay, SFC is a sequential function chart. Okay, means they will have like a flow chart. So means inside here one program, inside here one program. So inside here you can use ladder program, but this is the transition, they call transition. So inside here also will have a program. So the program inside here you can use depend on the PLC, but mostly the program inside here will be ladder or structured as well. These two. Okay, so whatever. And inside here they do like okay, program okay, start. Start. Then you put this one is a transition lah. T, let's say T1. This one, let's say this one T1, T2. Means what happened when I press that? What? So it go to the number 1. Okay. So what happened? Whatever program inside here can work. So let's say I put don't put start. Let's say I put a button like run. Okay. So now the program inside here now can work. Okay. Then stop. Okay. Whatever done. Then let's say they have a timer function. Okay. Then later inside here, let's say I have a timer function. Put timer. The timer Q timer output. Then I put T2 transition 2. So what happened? Once I finish this work, let's say I have a timer everything, then the PLC will jump from here to here. So now whatever program inside here, this program can run. Let's say sensor 1, motor 2, for example, can run. Then I can do it. Go loop, go back. So means okay, let's say here I have something. Let's say motor 2 is on. Okay. Then go back to the transition 1. So go back. So it's like you arrange the sequence, the flow, but inside each box like this, you will still doing some program, but you need to do something in this way. This one is mostly the what type of machine like CNC machines. Okay, because normally CNC machine, of course, they don't use PLC. Some they use PLC. In that case, okay, because they will have like a flow. I need to finish this job first, then only I go to this job. I finish this. Let's say when I finish this, I didn't get the result. I go back to the first. So something they do, something they draw, something. So they will see if T3 is okay, then we go back. If T3 is not okay, I mean if it is okay, go to next. Not okay, go back. Like a flow chart. So
these are the most common one, PLC. These languages. In code disease normally all will have all these language. Okay. Any question? Okay. Alright. Because code disease okay. Code disease a lot of videos in YouTube. You learn from YouTube?
No.
Eh?
I learned from my senior.
Oh.
Yeah.
Actually YouTube is very good.
But my company laptop cannot overlap YouTube.
That's the problem.
Yeah, lor.
That's the problem. They want us to do project, but if you want to source for the things very difficult.
They're very strict.
Because I know, because my friend company in Singapore, working in Singapore, say they restrict YouTube.
Yeah.
So sometimes what PLC problem, right? Because PLC problem, it got just now the red color LED, right? So if let's say if it is a new PLC for you, but for example, okay, this is a Siemens, so you know how to see if there's an error, you know how to see. For example, okay, go to open TI portal, go online and go diagnostic, you can know already. So this open, you go online, you go to online diagnostic, okay, you can know already what is the problem. So now you know the concept. The concept is you open the programming software, go online, open diagnostic. This is the step for all the model. Same thing. Okay, all the model. But now, let's say your company have a Mitsubishi PLC or error, right? So you know this is the concept, but you know how to use the software. Right? So if they able to give you access to the YouTube or something, right? Then you just go to YouTube. Fine, okay, because you know the name diagnostic. So let's go to Mitsubishi PLC error diagnostic. Show them you can get the videos. But the blog like this are very difficult to learn actually.
Yes.
Because if you ask me, most of the thing, because my boss, of course, he teach me the basics, everything. Then I follow my boss, he do training, then we do project, everything. Then from the project I learn about. Then sometimes, most of the thing, if I'm not mistaken, 50% of my knowledge actually from YouTube, internet, go to manual and learn. Okay, open the manual. Do you able to download? Download can. Because if you, in my experience, okay, if you see any red lamp or something, any PLC, they have the meaning in their manual. So later I show you how to get the manuals on that. Okay, so you can know where to download. So later when you have this, even the CAN bus program, right? You can get from the manual how to do the program in Siemens or Siemens. Later I show you. Yeah, because I never done CAN bus program. I've done Modbus, CCD, Profinet. Profibus is a Siemens run lah. But CAN bus I never tried before. But I can show you where you can get the data. Okay, good. Right. So this one is okay, it's not right. You understand the sequence, the importance of the memory, right? Okay, so this is where we use the memory. Okay, now maybe you can go to save as, just as save as lesson 2. Okay, save. Okay. Now what you do, you just delete all the files, all the program here. Okay, just click on the network one, okay, delete it. Yes, network 2, yeah. The tagging, we use back the tagging lah, no problem. Okay. Okay. Now what I want to do is, okay, put anomaly open, start.
output, I don't want to use the coil. Okay, you click here, double click here, S, set. Okay, then you put the motor. Yes. Okay. So this one is a set coil. Earlier is a normal coil. It means if the line is on, the output will on. If the line is off already, the output will off. That is a normal coil lah. Like this lah, right? Okay. So if this one is on, I on. This one is off, I off. Set coil means I just give one pulse enough. I always set. So if I'm using set, I don't need the latching. So I don't need the latching, or we call as a holding. I don't need. Then the stop button I cannot put like that. Because earlier I put the stop button because it's like a looping, right? The signal is loop back. So I need to cut off, that's why I put a stop button. So if like this I want to off, I need to put stop. Reset the same mode. So you add another one? You do. It's normally open. Stop. Then output. Okay. Yes, reset. Motor. Okay. So you save download. Monitor. Okay, you press the button. Yes, you see the light off already, but the motor is still on. So you can see the green one, right? So it means it's like this output is still on. The output there also on, right? Yeah. So you stop, then it's off. Okay, so it's a set reset. Okay, so it means the same thing like do the latching and cut off. So we have a normal coil and set reset coil. Okay, alright. Now you go offline. Okay, let's say I want to use a timer for this. For example, so you remember just now how the timer works, right? So if for this, if I want to use a timer, let's say, okay, I put it here. Put the motor. Normally open motor. Okay. Then the timer. Take the timer. Okay. The name to there. Okay. Now you put a timer value. Yes. Then okay. So the thing is, when I start, motor is energized. Then I use the motor to energize the timer. After the timer, I want to off the motor, right? So I have two options. Option number one is I use the reset here also. I just straight away reset because I want to this one, right? You can just copy this. You can copy paste this. Yes. Copy, just paste. Like this also can. Another way is I create a memory. And just now we create memory, right? Then the memory I put it down here. So when the memory on, I reset or I stop reset. So like this also can use. It's the same thing. So it's like the same what they call it, same process, right? Same process, but different type of programming. This is logic, right? Okay. Because logic you need to practice lah. Because like you practice, then only we can do some logic. Okay. But most important thing is the we need to know how to use these functions, how to use the software. But you a bit familiar with the software already, right?
Actually, no.
Not much.
Not much.
But you know how to download,
Yeah, no.
upload,
Yeah.
tagging,
Maybe yes.
then watch tables.
Stable, yes.
That's a main thing actually. The
Because
most
I use this function to do the simulation
Simulation.
on the spreader and the crank handle side.
Then you send data lah.
Yeah,
Send
send
values.
and receive data.
Send and receive the value lah.
Yeah.
So we just use the watch table, give the value, then you see that there you can get the value. Because you do the communication. So who do the setup for the communication?
Senior will set up for the first time.
Then you can just copy paste.
Yeah.
Oh.
Basically, our project is copy paste from the previous project. Yeah, so it's more easier for me. I just joined for 1 year.
Yeah, of course. But okay, but you just copy paste. But do you know the concept?
Yes,
Yeah, that's
this is
the
the
thing.
problem.
Yeah, that is the problem because of course sometimes the senior also don't have time to teach
Yeah,
or like.
because so much project on the same time.
Yeah, that's normal. I know because all the participants the same thing. They tell me that their senior don't want to teach them, or sometimes the vendor right they don't want to teach them all that. And I say yeah, of course, because now one they don't have the time to teach you.
Yes.
Another one maybe they don't not like they don't they don't have the patience to teach you.
Yeah.
They know how to do the project, but they don't know how to teach sometimes.
Yes.
Okay, I'll show you how to do this all these functions and okay. So now what we do a small project. Okay, small project using this one. So be familiar with the programming part lah. Okay. Then okay, so you save first. So just now I just save as, right? Save as because I just skip the configuration. So I will just do the again lah. So later for the project you totally create a new project. So you add the PLC all that. Okay. So far you already learned all these, right? Coil, timer, set, reset. Okay. So you understand the concept, right? Set concept, reset, timer, correct. So we need to do some projects, then we can understand better. Okay. Can I erase this? Okay. First thing is so whenever we do a project, first thing is we need to know how to read a flowchart and also do a flowchart. Because flowchart is very important when you do logic programming. I'll show you an example. This flowchart they call graph set, okay, which is similar to just now I do the sequential function chart. So they have two symbols. That is, this one is the condition, okay, and another one is function. Okay, condition and the function. So for example, I do a simple thing. So let's say the condition is the start button. Start. So push button we know lah, just push. Okay. So when I press start, what I need to do is, let's say on motor lah. Motor 1 on. That's all. Okay. Next, then at the same time I want to on a timer. Okay. For example, okay, I start motor on. At the same time, I run a timer. Let's say timer 1, 10 seconds. Then once the timer done, timer 1, Q means it's done, right? Once the timer done, what I do, motor 2 is on. For example, okay, motor 2 on, then motor 2 on, then motor 2 running on, okay. Then when I press stop PB, then both the motor 1, motor 2, both off. Okay, so this is a sequence for example. Now we do a flow chart for this. Now start PB again. So start push button. I on motor 1. Okay. So I on a motor 1. Then motor 1 must be continuously run, right? So if I'm using a coil, I need to latch. If I'm using a set, then I don't need, right? Okay. So I start motor. So if you see here sometime this latching is not in they didn't tell you in your flowchart. Right? In the flowchart they just tell you okay, start motor on. That's all. They didn't tell you when I start motor on need to be using a latch or need to use a set function. So that is the function of the flowchart. Flowchart will just tell you, okay, and this one is the condition. Okay, when I start, what I need to do. When let's say when temperature is high, what I need to do. When the cylinder reaches the position, what I need to do. Something like that. Okay. So then the same start button, according to this, right? Start motor on. Same start button on the timer. Okay. So let's say I put the start PB on the timer. This is the in Q PT. Let's say timer 1. Now, can the start button run the timer? Cannot. Can if I press, the timer will run, but the moment I remove, the timer will off. Because that is a function of TON. So what I do? So I of course cannot use this. So I need to use the motor 1. Because why? Because this and this on at the same time. Okay. And then now according to the flowchart, okay, when the timer done, motor 2 on. So now, if you want to use memory also can, the Q also can. But depend lah, right? Depend lah. So better to use the memory. So M0.0. So timer Q means the M0.0 lah. So when timer Q is on, it's on, the motor 2 on. So M0.0 motor 2. Okay. Do I need to latch? Here. Okay. No need, right? No need. Because sometimes we cannot, if you see sometimes we cannot imagine that. So the best way is to test it out. Once done, okay, let's say you cannot imagine whether you need to latch or no need. Then you just download and test. If the motor can on, then you see no need to latch, then no need to latch. Okay? So according to this one, actually no need to latch. Because why? Motor on. So motor 1 will be always on. So the output also will be always on. Then motor 2 on. Now, so if I press stop, motor 1 and motor 2 off. So if I put a stop button here, motor 1 will off, timer will reset, motor 2 also off. Correct or not? When I press stop, motor 1 will off, right? So when the motor 1 is off, the timer will go back to 0. Timer will reset. So this memory also will be reset. So I don't need to put anything here actually. But if you see that these are something like, here also need to put the stop button, correct or not? But if you put also, it's not wrong, but it won't work, that's all. According to the logic, it's not wrong. You can still put, no problem. But it's what? It's like useless, that I think. Unless you latch this. By mistake you latch this. Actually don't need latching. But if you put latch, then you must put the stop here. Must put. Why? Because if you didn't put the stop, so when you stop motor off, so this memory will off, but motor 2 still on. Then I need to put the stop button here. Okay. Then so this is how from the flow chart we convert into a program. So you see how I do the program. I didn't do the program whole thing. Then I test. Of course, I test man here, like in our mind. Okay. What I do one by one. Put it here, I put the motor, okay, then I see whether I need to latch or not. Okay, yes. Then I add a timer. Once the timer, motor 2 on first. Then just imagine, okay, how it works, everything. Then only we add a stop button. So same way, when we do programming also same way. We need to do one by one. Okay, good. Any question here? Okay. So we try to do one project and give you a project. So can I this?
Yes.
Yeah. This one is a same like just now we do lah, but I put into like a proper like a tank or something. Okay. So let's say we have a tank here. Then we have a pipe with a valve, right? Then we have a mixer. So this is let's say 1A, 1B. This is a mixer motor. Then here we have one pump to pump up. Okay. Now, so just very simple. That is, two chemicals come in, you mix, then pump up. That's all. Okay. Now, normally when we have a tank like this, okay, so we have a level meter. Get the level. So that one is an analog, because you will will have a value, right? Like a range. But we haven't learned analog yet. So what we do, I just put a level switch. Okay, 2 level switch. So I put here high level, low level. Okay. But this project is a bit easy to understand, like the first project. Okay. Then maybe on the last day we do some project according to your system or something. Okay, so it will be easier to relate. Okay. Stop. So this machine have a start button, stop button, low level switch, high level switch. Okay. Then for the input lah, for the output we have a valve A, valve B, mixer, and also a pump. So whenever we get a project, the first thing is the IO list, right? According to your wiring. Okay. So our input is we have a start, stop, low level, high level. Okay. Now, so according to the wiring there, okay, we can use the first button and the second button as a start stop. For the low level, high level, we need a switch. Okay, why? Because of course we don't have the actual tank here, so you need to imagine that. Okay, so when there's a water, it just on the low level. When there's no water inside, it's off. Okay, so we can use a selector switch. So selector switch is the fourth right, the fourth one. So I 0.3. So the 2 I skip, not using. The third push button not using. Then 0.3. Then output. Okay. RA, RB, mixer, and also the pump. This is Q0. Output, no, not the issue, right? Okay. But if you work in the actual system, then you need to follow this wiring. So now we see how it works. Okay, when I press start, okay, I start to fill up. I make it very simple program. Okay, when I start to fill, okay, just to fill here. Let's say it's already reached here. So just imagine, okay, it's already reached the low level. Okay, just manually on the low level. Okay. So when on low level, I want to, then I will still continue the valve A, but I want to stop here. Okay, so it means from here to here, I want a timer. 10 seconds. And so it means start valve A will on, okay, continuously run. Then the moment low level is on, I will run a timer. After the 10 seconds, I will off the valve A. Okay, so I will off the valve A. Then I will on the valve B. Okay, so valve B start to fill until the high level. So when you turn on the high level, okay, valve B will off, mixer will on. Okay. So for valve B, no timer. For valve A, this is the timer, right? For valve B, no timer. Then, so once I reach the high level, mixer will run. Mixer will run for, let's say, 10 seconds also lah. But it's up to you. The timer is up to you. how much you want to put. But sometimes if the timer is too small, you try to put bigger numbers, like 15 seconds or 20 seconds. So once you are familiar, then once you are confident, okay, that timer is okay, then you can reduce back the timer, 10 seconds or 5 seconds, okay, it's up to you. Okay. So it will mix for 10 seconds. After 10 seconds, mixer will off, the pump will on. Okay, so it will pump out all the chemical inside. So when the pump on, so we know that the level will increase, right? So high level will off because no water inside. Then you wait for a few seconds, then you off the low levels. Okay, when you off low level, then the pump will stop off. Okay, we don't care about this. Okay, okay. Later I will help you. Don't worry. Don't worry, I will help you. Okay, so just need to play. So when I start, I just need to play with these two switches only. Just so when increasing, just on both the switch one by one. Then according to your sequence. Then when the pump is on, then you off the high level first. After a few seconds, low level. When you start, when the valve A is not filling, okay, then you turn on the low level. Then you wait until valve B to on. Then you on the high level. Then you wait. So mixer will mix. Okay. Then after mix, the pump will energize. When the pump energize, okay, you off the high level. Wait for a few seconds. Off the low level. Okay. So later we will go over this. Okay. Now the most important is, okay, we have a project. We have a IO list. Next is the flow chart. Okay. So when I press start, the valve A is on. Can you see? Is it too small? Okay. Okay. So when I start, valve A is on. Okay, that's all. Then when low level switch is on, a timer lah. So I just put timer VA lah. Okay. 10 seconds. Then when the timer is done, timer VA.Q. Okay. The valve A will off. Valve A off. Then valve B on. Okay, finish. Then valve B will continue until high level. So when the high level switch is on, valve B will off, mixer will on. So valve B off, mixer on. At the same time, timer, mixer, 10 seconds, right? Then when the timer, mixer done, mixer will off, pump. Okay, so mixer off, pump on. Then, so here the low level and high level still on, right? So when the high level and both the low level is off already, the pump will off. That's all. Okay, but this is need to off first, then only the second off. Okay, pump will off, then the sequence finish. Then again I press start. Then again need to run from the valve in. Okay. For stop button, I make it simple. That is, when I press stop, PP, valve in, valve B, mixer, pump, all off. Okay. So you do a new project. Okay, do a new project. You add a PLC, then once you add a PLC, you do the tagging, then you can do. So before that, okay, if you want to do this, don't write everything, then you test. Okay, so maybe start valve A on, right? Okay, you stop here. For the valve A, you add the stop button also. Then you test start on, stop off already. Done. Okay, then next, when low level timer, after the timer, valve A off. Okay, finish. Then valve B on, high level on, valve B on. So every time one output on, off, okay, you stop there, you test. At the same time, for valve B, you add the stop button. Then mixer on, here mixer off, okay. So it's easier to do the programming. trigger valve be on?
Yeah.
Okay.
Because now
You mean
start.
here?
Yeah.
Okay. So actually, who on the valve B? What is the condition? The timer.
Oh, so timer will on the valve B.
Yes. So timer, you create the memory,
Yeah.
then the memory can on the valve B.
But the memory I already set off the valve B.
You can use back the memory one.
Use it.
Yes. Okay. Can I erase this?
Yes, done.
Can I? Can I erase?
I think I
Yeah. Take photo first. Okay. Done. Okay, so first you start, right? Okay. This one you done. Start. Using coil or set?
Coin.
Coil, okay, good. Actually, you can use set also can. Okay. So this one done already, right?
Yes.
Okay. Then the low level on the timer, right?
The low level I together with valve A.
Oh, so you put low level and one A.
Yeah.
Okay, no problem. Low level and the valve A on, the disposition no problem. Timer, right?
Yeah.
So let's say 10 seconds, then you put the output here, right? Memory
Yeah.
and 0.0, okay?
Mm.
Okay. So this is meaning this one, right?
Yeah.
Okay. So now I use this memory to off the valve A, yes, and 0.0. Then I use the same memory to on the valve B. Ah,
It can also be the same time on and off.
can.
Oh.
Because it's concept like a relay, like a relay. So means you energize the relay, right? Then from the relay, because relay have coil and also contact. So you energize the relay, then you can use their contact many times. Actually, that is the function of PLC. Got it? Yeah. Okay. So if you want a coffee or tea, you can make a coffee or tea also, can
But the naming for M0.0, right?
you can put any name.
No, because in the previous one I already put rough air off, and then
Or you want to edit, you can edit the name.
edit the name.
Yeah.
But the previous one will also change.
Yes, of course. You mean the which one?
Because now I hear right,
Yeah.
off right, so now I want to change to what we on. So
No, you
later if I
can't change the name. You must use the same one.
if you use the same.
So you can put the name as VA off, VB on.
Okay.
Because the same memory I use for both, right?
Mm.
Okay. So this is the same memory I use for both. So you can put like VA off, VB on. You also can, or you want to put like a common name. Like a common name. Let's say this is you put timer VA, right?
Yeah.
So if you want to put a common name, you can put it timer VA output or timer VA done, any name like a common name. Or you want to put a specific name. I know you already put the 1A off right
Yes.
earlier. So you want to use the same memory here, right?
Yeah.
Then you can put VA off, VB on. Or actually, that's the thing. That's the beauty of programming. You know, many ways you can do. Let's say you are doing like this. Okay, let's say you put on A off. You can create another one, M0.1. This one name it VB off. Then here you can use the 0.1 also. Okay. ask me,
Oh.
not necessarily this one because both are same, right? Yeah. So that is actually that's the good about programming. It's just the only thing is we need to know how. Okay, you know how I can come up all this, right? Because the thing is not about you know about the logic, you are expert. No. The thing is you need to know how to use that particular functions. That is the important thing. If you all know the concept, actually this one is like if you are, I will always tell my participant. Programming is like you're doing mathematics.
Yes.
If you know the concept, you can do many various. Okay, try. Make a coffee. use this memory to on mixer. Okay, actually you can use this memory here also. So this one is the high level on, right?
Yeah.
Here you go up because you see when the high level is on, like on this memory, right? So it means so I can use better. So I use this to off the VB, to on the mixer. I can use back to on the timer also. I can use back the memory. Yes, mixer, right? Then can use back the same here. Because why it keep on running? Because the moment is on, right? This memory will on, right? This memory will cut off this. Okay, it's working. Then mixer will off, timer will reset. Then this mixer will off this memory. So it's connect back because this one is always on.
But because I on here, right?
Yes.
Nothing to bring back the next.
Not necessary.
Oh.
Okay, you see like the earlier one we do like the morning, right? Okay, morning. Okay, we do like this. Okay, start motor. Okay, then I press the motor. Then I use the motor for the timer, right? Okay, why? Because I cannot use the start button for the timer, so I use motor. But in this case, you see, low level can on the timer, right? So same thing. Actually, you can use the high level to on the timer. So it will, okay, but why repeating? Actually, what there's a this one. Why repeat? Because you see, you use the VB off, right?
Yeah.
Okay. Then mixer, it will latch the mixer. But actually, no need to latch also because you see VB is always on. If this one is like on off, then we latch. Okay, but never mind, no problem. Okay, then mixer, the timer. This is the mixer off, right? Okay, you see, I put it the mixer off. Okay, the stop, no problem. Now you see. So the current is here. Then this is normally close, right? So with the moment this memory on, okay, I give the signal to the mixer, okay, I latch it, mixer, okay, timer start to run, right? This is the timer. Once I reach 10 seconds, this one is on, correct? Okay, but here I cannot see it's on, right?
Yeah.
It's repeating again. So, but according to the logic, after 10 seconds, this memory will on. So what happens when this memory on, this one will cut off this. Okay? Actually that is what you done, correct? That's what you wanted to do, right? Okay. Off. So when this one is off, so it will cut off this and the mixer. Then here also will cut off, here also will cut off. So this one, there's no more signal from here. But this signal will still here. Correct? This signal is still on. Okay. So when the mixer off, then this signal will off. So timer will reset. So when timer reset, I off this memory off. So when this memory off, this one back to normal, normally close. So on back. So repeat. But since this mixer on, cut off, the mixer will off here, reset, so it's very fast. So that's why I'm repeating. So the best way is, because still on, so I can use the VB off here, or the high level lah. So what happened? The moment here on, here was on. Then after the timer, this one on, so it will cut off only the mixer. So because my timer won't reset. If you use mixer here, then the timer reset. If I use the VB off here, so it continues. So this one will continuously cut my mixer. Okay, you can try that. Start on it, okay, go down. Okay, then we on the high level, okay, go down. Go down some more. Little bit, okay. Yes. But the pump is not on, correct?
Yeah, this one I haven't finished.
So, okay, actually I wanted to show you something. You go up. This one, right? Actually, if you because it's a normal coil, right? You no need to reset also. I can use the VB off here. Normally close also can. Same like this one, right? You go up. So this one. Here you normally close, then here you normally open, right? Same thing. You go down. So this VB off, here you put normally open here, then you can use here normally close. No need to reset like this also. If no, can. If you want to reset, still can, no problem. But if you ask me, you put like a latch. I mean like they call branch. So if like this, it still can, but sometimes who want to read the logic, right? Sometimes they cannot understand this. So they, you know what happened? They will thought, okay, when high level on, oh, it will reset first, then only the VB off. So they will, misunderstand here, confused. But if you do it like a branch here, then they can understand, okay. So when the high level on, I on a memory, at the same time I reset. This one actually this one also at the same time, but sometimes some people will confuse. Okay, try. So this one how?
will be high level and low level all the same time in the bump to off, right? But
Okay, never mind. We do. You start.
Start.
Yeah, start. You off all that. Okay, start. Okay, let until the low level. Start. Okay, low level on. Okay, you go down. So your idea is when high level and low level off, you want to reset, right?
yeah.
Okay. You off the high level. Okay. When you off high level, your mixer off is off, right?
Yeah.
But you want the pump is still on, correct? Yeah. Pump is still on until I low level, right? So you just latch it here. Latch the pump here. Correct. But there's many ways to do it. Yes. Pump. Latch the pump, yeah. Or actually you can do this way, or okay. Actually this high level, low level, just now you put it here, right?
Yeah.
Right. But it's not working. Why? Because you put normally closed. If you put normally open, then it would have work. Okay. So you see, because you see like where is it? Like high level. Because here is when both is off, then only I want to off the pump. So it's like this. Okay. So the mixer off. Of course need to latch that this one, right? Because why? Because when the high level off, then this one will off. So I need to still hold okay. But okay, of course off is here. Then the high level just now, low level you put normally open. Cannot work. So actually it's supposed to be normally, you put normally close, right? Here you can put normally open. High level, low level. So when there is the water in the low level, this one already on. Then when there's water in the high level, this one already on. So mixer on, pump on. Then after high level off, so if this one off, you see we cut off the pump, right? So what we do, use a branch. So when the low level is on, high level on, so the system running is like a wiring like that. So if you flow here, flow here. So the moment high level off, this one will off. Of course, this one also will off, right? So pump will still run on this signal. So when the moment low level off, then only the pump will off. So you can use this way also, or you want to use the reset way also. Or the best one is, okay, let's say you want to put like this, right? Better understanding is you can put this one. I think maybe you can change here also. The mix of, okay, put pump. So need to latch, right? Then the pump here you put normally close high level, normally close low level, reset. Okay. So this one need to latch, right? Instead of latching, actually you can use the set here. Correct. Instead of latching, I can use the set. So can create a better understanding of this set. Then, but so the stop button you cannot put it here. The stop button. So the stop button you can put it here. You can create a new reset or stop button directly like this. But the one, but this one is like what logic, right? Programming logic. So it can be many ways to create a logic. There's no particularly you must follow this only. Different people, different based on their understanding lah. Okay, no problem. Okay. So the most important thing is you need to know how it works. So when you do this one, you know how it works. It's easier to do any type of program. So later when you do, like you say, okay, your senior already done, then you copy that, then you do that. Okay. So later on you will understand better. Okay, why he doing this? Why he put memory here? Why not he don't use the one address? Right? So you can better, you can have a better understanding. If you have a personal laptop, I can install this software. So I can install the software, then you can just practice at home, do projects. Of course, I need to allocate that time. That's the thing. Because the time is nowadays cannot allocate time really.
Yeah.
Very difficult to allocate time for learning. But you're still young, you can learn. Okay. Any question until here?
So the here called the launch type.
Latch.
Latch.
Yeah.
Is latch is same as the holding.
Holding. Yeah, it's the same thing. It's the same thing. Yeah. It's hold the value, right? So because like this, you send a very simple. I send a signal to pump. Don't care pump or something. Okay. I have a normally open. I send a signal to this output, a coil. So if I want to hold the coil, so I latch or holding also can, no problem. Why I already used to name the latch because in library the set, right? The library they call latch. They call latch unlatch library. So I used to that word. But it's a holding, yes, correct.
So how can this reader convert to function mode?
Convert to function, cannot.
Cannot.
That's the thing. Okay, it cannot directly convert. Okay, I go offline. No. I think you can. Yeah. What do? You right click this name. Yeah. Switch programming language. Yes, can. FB. Yes. So can you see it's an OR function? This is an AND and this is NOT. Because they don't have an AND NOT function. So they use an AND, this is an invert. Like this. you go up. Okay, start or stop. Okay, this one there's a two normally close lah, right? Invert lah. Go down. This end you see, it's like a normal, right? It means this signal on means 1, 1. That's output. Here is 1, right? Actually, this one is a 0, 0. Actually it's a 0, 0 lah, right? So when it's when become 0, 0, it means it will invert. So become 1, 1, 1. So when this one becomes 0, 1, it will invert the value, become 0. So it's not an AND anymore. So it will cut off. Function block. Actually, function block also interesting.
Yeah, because a lot of time I use the function block to
Oh.
learn that at the first.
Oh, I mean the code is it?
Yeah, so this is and this also in function block.
I mean the TI portal.
Yeah.
Oh, using function block also.
Yeah.
Oh, okay, okay. But yeah, function block because can also. But you need to be familiar lah.
Yeah.
Familiar with the block and you can understand.
So now I also in the learning process with the function block.
Function block, yeah.
Because some function block in codices is complicated.
Yeah. You mean the sum function block? You mean the function block?
Yeah, function block inside of function block again.
So in that case, you need to, what you can do like the help, I show you the help, right? You can use the help to understand how it works, everything. So same like this. It's actually good because, but the only thing problem is you cannot change to the SCL, the structure text, cannot. But the SIMATIC manager can. The older one, that one is using this one, right? That one, SIMATIC manager, you can write a program in ladder and can convert that into structured text. They call structured control language. So you can learn that also. Actually, that's how I learn. Because for me, I'm very familiar with this one. What I do, I just write a program, I convert that into function block, then I try to learn. I convert back into the other like formats, right? I try to learn. But this one cannot. In TI portal 1200, from ladder I can convert to FBD. From FBD I can convert to ladder, yes I can. But from the ladder to the SCL cannot. You right click here. Go to, can you see? Oh, statement list here. So SCL cannot. I cannot convert. But I can create a new block with STL, yes. But ladder to convert cannot. But I can create new. Yes. Actually, what you click add new block. Open. Go to function block. Example. This function block means it's a user-defined function block. You take your own block. Okay. You click ladder main language. You see. Ladder FBD SCL. This one is a new one. It's a cost and effect matrix. It's another type of I don't call it as a program. It's like a table. Normally, cost and effect matrix is when you create a program or when you create a system, then you will have like cost and effect matrix. Means okay, when I press start, okay, what happened? So like for testing purpose, they will add this. Then if the temperature is reach 20 degrees, okay, what happened? So something like that. Okay. So that's what this one, the cost and effect matrix. Okay, good. Any question? Until here, later tomorrow or you learn all this.
Can I have the TIMV 18 the installer discount? Because this project I cannot open V79.
Oh, yes.
So that in the future I want to refer back, I can open in my computer report.
This laptop.
Yeah, but maybe I need to ask my company IT first how
Yeah,
should
yeah.
I get from you and want to install here.
Yeah.
Because if it's not wrong, if I use the pen drive to plug in
Of course, you cannot read.
Yeah.
They will block.
They will block.
Yeah. So you just tell them that you learn version 18 here, so I want to install version 18. Because the license can use back the same license. So no need to put license. The license can use back the same license. Just need to install the version 18 only, additional. So in this laptop you have 17 and 14. So of course the laptop will hang. We will have both. That's why normally here, because we have a lot of laptops, right? So sometimes, because my laptop I use install version 18. Then I have a few laptops install version 15, 15.1. Then some laptop is version 13, 12 and 14. So all the laptop I have. So whenever I go troubleshoot, so I ask them first what is the version. Let's say they don't know. So I will bring my laptop and one backup laptop. So let's say it's 18, okay, I can use it. Some other version, then I come and bring another one. I don't let it install in the one. Which we call hang.
Yeah.
Or you can create like I think because yours is stroke strict right, the IT. If no, you can use a virtual window.
Virtual window, yes, we have.
Hmm.
But the virtual window is sometimes slow.
Yeah, of course.
Yes.
For virtual
I
window,
don't
you
like.
must your laptop must be very powerful.
Yes.
How many GB RAM is one?
This one, I'm not sure.
For me, if you ask me, virtual window must be i7. Intel i7, RAM 60, at minimum 32 GB.
I think need to see the setting.
Yeah, I can see the thing. So minimum 32 GB and SSD at least 1 terabyte.
But this computer, although buy early this year, already FaceTime, already blue screen. So several times when I do the troubleshooting.
When you do troubleshooting with the system.
Yeah.
Yeah,
Blue
because
screen
now.
then here will off and then I need to restart.
Yeah, because nowadays the Windows update so much problem.
Yes.
Windows update. That day also I was using my TikTok. Then I'm following one guy he sell laptops. Then he refurbish laptop repair. He told in his one of the video that there's a new Windows update that is a problem. So even Microsoft also released a new they just release a memo that don't install that. So wait for the next update. So those who already installed, go and uninstall the Windows update. So that's why normally my laptop Windows update I always not auto. Whenever I need updates then only.
But you don't run auto, until the sometimes will force you to update.
Yeah, of course. Until sometimes, that's the thing.
Yeah.
So because that day the version 18, right?
Yeah.
I think 4 months back. 4 months back, I installed as on security update. I installed. After that, I cannot open my Windows version 18 ready. Yeah. Then because I go to the Siemens website for the TI portal, then they mentioned that the new update they have some integrity issue with our TI portal security functions. So there's two options. One, you uninstall the updates, or you install latest version of what they call the license manager. So what I did is I install latest version license manager and I uninstall the update. I do both. Then only it can work. But if let's say you are the company you are a programmer, better to have one laptop which is not controlled by IT.
It's hard.
Very hard. No, company very hard.
Because our
in their laptops. Especially, okay, if let's say your company is fully Siemens or Siemens plus one or two, then it's okay. Some company here, I know one company in Senai, they have 40 plus PLC. So which is include Omron, Mitsubishi, Siemens, Delta, Siemens, another one is called Shili, right? One also Mitsubishi, and another one is Panasonic. Seven type of PLC. I go and upload the backup the program for them because there's one machine that suddenly power trip, right? So that PLC got battery. So some PLC the battery is for the keep the value. Some PLC the battery is to keep the program. So battery is fault. They didn't know that because it's inside the panel. So power trip when they on back, no problem. All lost. So they don't have the supplier contact everything. Luckily the ladder they printed in they print and keep. So they give it to me the ladder. I rewrite the ladder and I download.
They didn't have the
Backup. No, they don't have programmer. Mostly companies don't have. Only some companies only have. They are internal programmers. They do the job. Yeah. So this company, so what happened? So they know the value of the backup. They asked me, but there's a small company, small. So they asked me to back up like around 40 PLC. I go there like 2 days, back up one by one. Very fast also. Backup is just like few seconds only. But sometimes the cable won't work. You need to check the cable. Suddenly the software cannot work because you need to install 7 software in your laptop.
Yes.
Software cannot work.
Take time.
Yeah, so many issues.
Understand.
Yeah.
I also sometimes like this. Suddenly, got the error, but I check. I need to check software, hardware,
Yes.
the program side,
Yes.
the wiring.
Well, everything.
Yeah, everything possible.
Yeah. Need to check. And I will show you how to do it. Whenever you have an issue, error, I show you which step to do first. So later on, whenever you have an error, so you can know where to start. Because sometimes you don't know where to start. Some error, right? This one is what error? Whether programming error, or hardware error, or wiring. Sometimes you cannot predict, right?
Yeah.
I show you. Okay, good. Okay, so whatever you done, you can save that. Then we can continue tomorrow. So you are from Johor, is it?
My house not here. My house is at Tampa.
So now you are already 1 year here.
Yeah, 1 year. But also is hard. During this 1 year is also hard for me.
Of course.
Because my department got manager and senior and me only.
Only
So sometimes
3%.
they are busy with the more important things.
So you are on automation
Electrical department.
or electrical department. So electrical department you handle electrical and also automation.
Yes.
So there's no like automation alone don't have lah.
No. Our company not have the automation department. So all the electrical they have.
All the automation everything fall under electrical lah.
Electrical. So the electrical cannot program the PLC, right? So how the spreader cannot run. Yeah. So it's most important for
Yeah.
the
Okay.
yeah.
But never mind, you learn all this in your first company is always good. Because very rare people involved in automation. Especially in companies. If you know that, then for your future will advantage. So you know electrical, you know automation. Actually, it's important to know electrical. For if you want to do automation, right, you need to know the electrical.
Yeah.
Yes.
how to do
How it works. The most important is not actually how to do wiring. Because wiring, for me, if you ask me, because we do, because here we do panel also. So I can design a panel, I can do wiring panel. Because panel wiring is sometimes is depend on the designing only. But if you see like a big project, right? So it's not like one person do that. So one person give all the details, so he will tell all these components. So okay, and the who designed the wiring, right? Just in the software, just pick here, just connect, okay, then fix it. It will give to the guy who do the wiring. So the guy who do the wiring can see the wiring later, he just connect. Sometimes they don't understand also why they're using that. But if you know how the things works, that is the most important thing. So like you said, like the speed canvas, right? The communication. There's a one is the connector, right? It's like what from here to here is connect, right? Okay. So the most important, you need to understand how it works. Actually, three cable, right? It's very simple. You know what is three cable? Transmit, receive, ground. You know what protocol they use? They're using the protocol RS485. Because RS485. Have you heard about RS485?
I think I hear from my manager, but they did not explain more deeper.
Yeah. RS485 is the protocol like the communication between device to device. They have two types. One is RS232, another one is RS485. So 232 means it's like 1-to-1.
Oh, it's a hub. The hub.
It's like a 1-to-1. Means not it's something like one device to one device.
Oh.
So only both of them can communicate. 485 means that is RS232. 485 means one device can communicate to multiple devices. So that is called 485. So what happened? This is the base protocol. So what happened? Siemens take this, convert in. Siemens use this protocol, do some modification. They make it into Profibus. Omron take this one, do some modification. They make into TrueBus. Like what? Mitsubishi take this one. They convert, use the same protocol, use that, convert that into Sicily. The same go for canvas. So canvas is like, so what happened is they make the communication easier. But the base protocol, if you see go deeper like into canvas, they use this type of protocol only. Actually, automation very big. If you see, if you learn every day one thing. Okay, good. Whatever you done, just send it. Yeah. If you have your personal laptop, yes, you can bring. I can install for you.
I think personal laptop no much space already because I use it for my
university one. Yeah, okay. Because you just only finished one. 1 year back. This is my card.
Okay.
So after the training, right? After the training, we give free consultation. So after the training, you bring any projects. So when you don't understand, you start somewhere, you know what to do, you can contact me. No problem.
Okay. My manager and my senior got take the SAM training last year.
Oh, I also do. Yes, sir.
They told me
Oh.
that time also only there are 2 guys only.
Yeah.
Right?
Yeah.
I think
See,
it
what
also
they mean? What is the name? Their name, your manager and your senior?
Manager Mr. Ng,
Okay.
and other one senior is Malcolm.
Malcolm.
Yeah. Not remember already.
Last year, they say last year, is it?
Yeah. They told to me last year. Last year or
A year before now.
yes.
Oh, okay, okay. Malcolm, yes. No.
Yes, no.
I think 2022.
Oh, 2022.
Mm.
The laptop I need to shut down.
Never mind, only can leave it over this one.
Never mind.
Yes.
So this book is
For you, yes.
two books.
Yeah, that is our company profile. That is the what manual, yes.
Okay.
Mm.
Maybe I let
Okay, just can leave it here. Later on, maybe later on, Tuesday, Wednesday, you can take back.